Okay guys, let's start with the revision for the math periodic. Hope you guys are doing well, and we'll start with the section 4.2.1. So this section deals with implicit differentiation. Traditionally normal derivatives we do is with one variable, x, y, z, whatever, but it's with one. But sometimes we're given functions like this with two variables. So then our normal definitions don't work, and that's why we use implicit differentiation, where we treat one variable. In this instance we always treat y as the function. So let's just solve activity 2 number 1. Why I'm not solving activity 1 or activity 2 number 3 is because activity 1, the way you solve it is given in activity 2 number 1. We will do it, and activity 2 number 3, there's a grid question similar to that. So let's start without any further ado, and I'll give you guys a few seconds to solve. Okay, let's check it together. Given 2xy plus y squared equals x plus 1, find basically y double prime. So basically activity 1 needs us to find y prime of this. So we are doing activity 1 in this question as well. So to find y prime, it's basically you use the product rule kind of thing here. It's two variables, so it's 2y plus 2xy prime plus 2y prime equals 1. Take the y prime out, you get 2x plus 2y equals 1 minus 2y. So y prime is equal to 1 minus 2y over 2x plus 2y. And this is actually the answer for activity 1. So yeah, now y prime is equal to 1 minus 2y over 2x plus 2y. We want y double prime, so we use the quotient rule. So we get minus 2y prime into 2x plus 2y minus 2 plus 2y prime into 1 minus 2y all over, let's take the 2 out for now, x plus y squared. Now basically, since we have y prime, so we have to substitute 1 minus 2y over 2x plus 2y into 2x plus 2y, 2 plus you just substitute 1 minus 2y over 2x plus 2y, parenthesis 1 minus 2y over 2x plus y squared. Now you have to go through the hassle of a common denominator, simplifying. I'm not going to go into all that. It's simple algebra, and the final answer of y double prime that you should get is, now don't worry if you get a very long answer and it's nothing similar to this. You may have just gotten the expanded form. I've simplified it. 4x plus 2y plus 1, all of that over 4x plus y cubed. So this is the way how you solve it. Okay guys, let's start section 4.4.1. This section deals with linearizations. We use the linear model of a function to obtain estimates. As we can see, obtain an estimate for given values. And this section deals with getting the equation of the tangent line and finding estimates for certain values. So let's start with example 1, as this is on the revision sheet for the periodic. Find the linearization of f of x equals square root of x at x equals 4. Use the linear model of f to obtain an estimate for these values. Compare the estimates with the answers the calculator gives and comment on the results. So I would give you guys a few seconds to solve, and let me just help you guys out. Split this question into 3 parts. Now when I've split it with these lines, now it gives you certain steps to work towards. I'll give you guys a few seconds. Okay, let's check it together. First, we find the linearization of f of x root x at x equals 4. Let's look at the point first. Since it's 4, we take the square root of 4, it's 2. So this is the point we're looking for the tangent at. What is the derivative? When you have to find the tangent, you have to find the slope. F prime of x is 1 over 2 radical x. Substituting at x equals 4, we get 1 over 4. So this is m, which is the slope of the tangent. Now we use y minus y0 equals mt. Remember, x minus x0. So if we substitute, we get y minus, we take this value, 2 equals 1 over 4 x minus 4. When we finally solve, we get y equals 1 over 4x minus 1 plus 1. But this is not the linearization, right? We're looking at the linearization. If they wanted the tangent, this is the tangent. One simple step, L of x is equal to 1/4 x plus 1. And this is the linearization of f of x equals square root of x at x equals 4. Now we move on to the second part of the question. Use the linear model of f to obtain an estimate for square root of 4.1, square root of 5 and square root of 6. So moving on, let's just have the quick equation here. And let's just remember what f of x is. They wanted square root of 4.1. Well, let's look at square root of 4.1. Isn't this f of 4.1? Because if we put 4.1 in x, then f of 4.1 is square root of 4.1, right? And we should know that the definition itself says this is approximately equal to. Linearization will never give us an exact value unless we're looking at the exact point, which is 4. So this is approximately L of 4.1, right? Which is approximately equal to, if we substitute 1 over 4 into 4.1 plus 1, which is again approximately, let's quickly check, 2.025. Same thing with radical 5 is equal to f of 5 approximately L of 5, which is again substituting, we get 5 divided by 4 plus 1, 2.25. And square root of 6 is f of 6, which is L of 6, 2.5. We have answered the second part. Compare the estimates with the answers the calculator gives and comment on the results. Basically, they want the exact values. Now we have square root of 4.1. Let me get the exact value. All you have to do is plug in your calculator. And we get 2.0248. I'm not going to write more digits. It doesn't make more sense. Square root of 5. Let's take the exact value. Is around 2.236. And the square root of 6. I'm just going to draw a line here. Calc. So we know that these are our exact values. And the square root of 6 is equal to 2.449. Let's put a 5 here. Okay. What do we see here? Well, we see, and this is answering the second part because we've compared it with the estimates. Comment on the results. We see that the values that we're getting with the linear model are extremely close. 2.025, 2.0248, they're rounding errors. But one thing to notice here, the closer we get to 4 or any point that was given in the question, not got to 4, get to 4, the more accurate the answer. What does this mean? Let's see. What is the difference from 2.0248 and 2.025? It's 0. Let's just quickly be correct. 2.025 minus 2.0248. 0.0002. The difference between this and this, 2.25 minus 2.236, would be a bit bigger, 0.014. And let's check the last one, 2.5 minus 2.4495. It's 0.0505. So as you can see, the differences are getting larger. So that shows that the closer we are to 4, which is the main point where we're taking the tangent, the more accurate our answers get. One more thing you can look at is, are your estimates underestimates or overestimates? Are you getting more than the real answer or less? In this case, our answers are overestimates. And one way to show this graphically is, I will be showing it to you right now. How does square root of x really look like? Just draw a quick graph. Doesn't it look like this? It's concaving down. Important thing. When you draw the tangent, it looks like this. So when you can clearly see, let me draw this with red. This is, let's say, 4. We can very clearly see that any of our answers will be over. Let's say this is 6. This is more than the real value. The real value is actually this. So that's why whenever the curve is concaving down, our linear model will always give us overestimates, and if it's concaving up like this, it will give us underestimates. And with this in our minds, let's solve the activity. I'll give you guys a few seconds and then we'll check together. Okay, let's check together. First, we have to find the linear model. So we derive this f prime of x, but first obviously we have to find the point. So it's at 0 comma 0 plus 0 1. F prime of x is x squared plus 1 to the minus half. Chain rule, it's minus half x squared plus 1 minus 3 over 2 times 2x. Well, this gives us minus 2x over 2 x squared plus 1 cubed. Cancel, and this is our derivative at x equals 0. Now we can see this is 0, so our slope is 0. Our slope is 0 because if we substitute anything, 0 over anything is 0. Now we get y minus 1 equals 0 into x minus 0, which leads to y equals 1, or L of x equals 1, and this is our linear model. Obtain an estimate for 1 over the square root of 1.04. We cannot immediately put this into the answer, even though anything we put will get 1, because the tangent is a horizontal line, but we have to use the right x. So we say 1 over square root of 1.04 equals 1 over the square root of x squared plus 1. 1 is the same, but now we have to split this. Can't we write this as 0.04? Oh wait, yeah, 0.04 plus 1. If we're just splitting it, we can write that, right? Now what squared? X squared equals 0.04. Then what does x equal? X is equal to plus or minus 0.2. Substituting here, f of 0.2 is approximately equal to L of 0.2, which is approximately equal to 1. And this is your answer. Let's do some grid questions related to this, shall we? Okay guys, let's move on to section 4.5, which is the next section required for the periodic. This section deals with solving equations graphically, solving them by rearranging, and what better way to learn than by solving this quick activity. So let's do activity 2 number 1. Show that the equation x minus e to the minus x equals 0 has a root between 0.4 and 0.6. Use the iterative formula xn plus 1 equals the square root of xn e to the minus xn with x0 given to be 0.6 to find the root to 1 decimal place. Okay, I'll give you guys a few seconds. You can solve and then we'll check together. Okay, let's check together. First step, to make it very simple for us, let's just quickly call this f of x. So f of x equals x minus e to the minus x equals 0. No, it's not equal to 0. It's just this. Now, next step, we have 0.4 and 0.6. I'm going to solve it and then I'll give you guys a few seconds to remember something. So let's see. F of 0.4. I've solved it beforehand. It is a negative value. You guys can find the exact value for yourselves, and you can even write it and then say, this is negative, but you can easily write negative. And f of 0.6 is positive. Seeing this, what do you guys remember? We learned a theorem on this. Intermediate value theorem, IVT. So what we should say is, as f of x is continuous on the closed interval 0.4 and 0.6, it is definitely continuous because we know x is continuous and we know e to the minus x is continuous. if f of x and g of x are continuous, f minus g of x is also continuous, and f of 0.4 comma f of 0.6 have opposite signs, that means one is positive, one is negative, opposite signs, then we have fulfilled all the conditions of the intermediate value theorem. So then by IVT, f of x has a root between 0.4 and 0.6, and that this is the wording I should use in the written part, just to give the reasoning why why you did this step basically. Now that we have this, now we look at the iterative formula. We had xn plus 1 equals square root of xn e to the minus xn, and we also had given that x0 is 0.6 and they want the root to one decimal place. Now what we're supposed to do is you're just supposed to keep on substituting the values in this equation, just press equals 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 and recording the values, and the moment you get two answers that round to the same number in one decimal place, that's your root. So we have x0 equals 0.6. I believe you guys can easily substitute, all you have to do is 0.6 times e to the minus 0.6 and square root that, and you just keep substituting. So in this case it would be smart to take it to maximum 3 decimal places, because maximum it will affect that. So as we can see here, the rounded value is 0.6 approximately, but it's better to be 100% sure. The next value you get is 0.569, and maximum x3 you should take is 0.567. In all of these cases it's rounding to 0.6, so what we say is the root is 0.6 to one decimal place, and that's how you solve activity 2 number 1. Let's do number 2 now. Using the same set of axes, sketch the graphs of y equals e to the x and y equals 1 over x. Okay, I'll give you guys a few seconds, you can solve and then we'll check together. Okay, let's check it now. See, you guys don't need to, if you want, you can do all the, derivatives and, y-intercept, x-intercept, it's good, but, it's a written exam, you want quick, but don't do a rough sketch, they want it as a question, so, it would be good, let's call f of x equals e of x and g of x is equal to 1 over x, just take a few points. I hope you guys know how to solve it, graph it, and then when we graph we get x and y. You guys should know that e to the power of 0 is 1. It's a very important point. So e of x tends to look like this, call it f of x, and you guys should know that 1 over x, to get a 1 over x, all you have to do is take a few points, right? And then that gives you the general shape. It is asymptotic to both axes and it looks somewhat like this. It's a very rough sketch I've done because I cannot do a proper sketch in this app, and that is how you're supposed to guess the graphs, and this is the point of intersection, important point. B, reduce the number of real solutions of this equation e of x equals 1 over x and show that this equation may be written in the form x minus e to the minus x equals 0. Well, now if you can see, there's only one point where they're intersecting, and then we call this is a point, so it has one real solution. And now let's see how we can rearrange this equation. We see that e of x equals 1 over x. Now we take let's take the reciprocal, let's flip them. So that's x equals 1 over e to the x, right? When we solve this part, we should get x equals e to the minus x, because it's minus power, and then we just take this to the other side, we get x minus e to the minus x equals 0. And wait a second, this is looking extremely familiar. It's the same one from activity 1, but we shouldn't say that it's the same question, it's a different question, so let's resolve it. Now this time we have to show that it has a root between 0.5 and 0.6. So okay, let's call this new equation h of x is equal to x minus e to the minus x, and let's see, h of 0.5 and we take h of 0.6, and what do we get? H of 0.5 is equal to minus 0.107, which is negative, and h of 0.6 is 0.051, which is positive. Then we do the exact same thing, intermediate value theorem. If you guys want the wording, you can rewind a few seconds and see what I said in number 1. Blah 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 dot dot dot, we have a root. Let's move on to part D now. Taking x equals 0.6 as the first approximation to this root, let us use an iterative equation to find the root and giving our answer to one decimal place. Okay. Now we have as a given, and we can easily use that. We can just say x is equal to e to the minus x. All I've done is taken e to the other side, and then I can easily say x n plus 1 is equal to e minus x n, and we had x0 to be given as, what was it given as? 0.6, and they want it as one decimal place. We just keep approximating, we get 0.5488 dot dot dot, and for x2 we get 0.5776358 dot dot dot, and x3 we get 0.5612236194. This is all the numbers that are showing in my calculator. As we can see, 0.57 and 0.56 are extremely close values. Why I did not stop at 0.57 is because these two values round to different numbers, right? They want one decimal place, and since they both round to 0.6, our root is again 0.6 to one decimal place, and this is the final answer for part D. So now that we have done all the applications from the book, let's do
This one's really easy. It kind of like, you could say, self-explanatory. They're just testing you if you know how to split the summation, if you know how to split the constants from the variables when you do the summation. So pretty much, let's cut into the chase. Let's just split them. You end up with m cubed from 1 to 25 plus 2 outside into summation of m from 1 till 25 plus 1 summation of 1 from m1 till 25, and this translates to that, this translates to that, and this translates to that. So just immediately write the rules. In here it will be 25, because your n is going to be the one above always, and so 25 times 26 squared over 4 plus 2 into, do not forget that there's a 2 outside, and then you have a fraction over here. It's 25 times 26 over 2, these cancel, and you have plus 25 over here, because you just end up with n, and then you end up with the answer of 106,300. Fairly easy, to be honest. Okay. So for this exercise, we're going to use the summation rule to find the estimation of the area, not equal or exact value, because we're given a certain number of intervals. So even if you're using summation with the limit, it can give you the exact value. In here, it's just a certain number of intervals, so no limits. So I just did the integration just to show you that you're going to get a value similar to this, something within that range, not like, for example, -77 or let's say plus 108. These are really far values, just for you to see. Even if you get 15, pretty far. This is like 1.33. So yeah, let's keep on going. The very first step to do is find delta x. So b minus a over n. B is 1, A is 0, and n is 4. So 1 minus 0 over 4 gives you 1 over 4, length of the interval. And immediately your second step is to find the intervals themselves. You start with 0, so 0, plus 1 over 4, and then repeat 1 over 4, plus 1 over 4, you get half, and then again you repeat, add 1 over 4, you get 3 over 4. Again you repeat, add 1 over 4, you get finally 1. So we're going from 0 to 1 over the course of how many? 4 intervals, which is exactly what we want. So we know we're correct. We want ck. Ck is given here by right endpoint. So this is right endpoint, right endpoint, right endpoint, right endpoint. So these are our ck's basically. So when you do the summation, we need those ck's. But to be exact, we actually need the f of ck, which is some of the mistakes I used to do back then, which I don't want you guys to do. Which is, don't immediately use, even if you end up, let's say, writing it in the formula, which is what I used to do back then. I still end up, when I hold the calculator, I still end up putting this times that plus this times that, which is wrong. You need to put this in here, find f of ck, and then just multiply it there. So I already found the values, so I'll just be giving them to you guys, just save time. To be 9 over 16 for this one, 5 over 4, and this is 33 over 16, and this is 3. These values you've gotten from putting 1 over 4 here, putting half here, 3 over 4, 1, and so on. So the rule says summation of, and we're going to use ck, so I'm going to say k. If they use I, I'm going to use I. So k is 1, we want 4 intervals, so this is 4, times, or summation of delta x times f of ck. By the way, delta x is a constant, they're equal intervals, so just you can take it out, save time, especially on a calculator, because on a calculator you can just, if the delta x is outside, you're just gonna be multiplying by a number, like something, times, and when the calculator you put plus, 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 whatever expression you have over there. So with that, delta x summation from 1 till 4 of f of x, ck and then from there delta x is what? 1 over 4 into, I said each one of those, I gave them the values, so 9 over 16 plus, this is 16, plus 5 over 4, plus 33 over 16, and finally plus 3. If you add them, you end up getting and multiply. If you add them actually you get 55 over 8. If you multiply by over 4, you get 55 over 32, which is approximately 1.71. Actually, exactly, if you calculate it, exactly 171.875, I think, which is roughly close to 1.333. So we know we're good, and this is pretty much how to get the value. So for this exercise, we're not given a certain number of intervals, so you just have to use Riemann's sum with n intervals, which is exactly this. And I'll be giving you tips on the way, so I prefer if you see this from beginning to end. So our very first step is to find delta x. Delta x is b minus a over n. N stays n, b is 3, a is 1, so 3 minus 1 over n, giving you 2 over n. The easiest way to find ck, which is what you need to find next, is to use the intervals. So you're starting from 1, so 1 plus, again this is not obligatory, it's just to find ck, an easy way to find ck. 1 plus, add to n, so 2, you start with, of course, a, and then 1 plus 2 over n, and then again 1 plus 2 over n, comma 1 plus 2 over n plus 2 over n, so 1 plus 4 over n, and then add 1 last time. You get 6 over n for that part, for the small with the over n part, and then you just continue if you want, but you should stop really here, not to waste too much time. And so this helps you find ck. Ck is 1 stays constant, so write the constants. N is again a constant, nothing changing here. 2 became 4, became 6, you're doubling, and your actual only changing factor, which is k, goes from 1 to 2 to 3 to 4, so the only way you should have this is 2 times k. And we don't need our ck directly, we need f of ck, which is really important. F of ck, just put ck right over here into this equation. So you get 1 plus 2 into k over n squared plus 4 into 1 plus 2k over n. 1 squared, again 1, plus 2k over n times 1 times 2, you get 4k over n. If you're confused, all I did is a plus b squared. The middle value is 2ab, pretty much, that's it, 2ab. Plus the squared, so you have 4k squared over n squared, plus 4 into this, so you get 4 for this small part, and for this one, 4 times 2, you get 8k over n. And let's simplify further. If you don't mind, first of all, these are like terms, and if you don't mind, I'm going to start with this, you know, like as in descending order of power. So 4k squared over n squared, because it looks nicer, plus 12k over n plus 5. So we have our f of ck, we have our delta x, we're ready to go with Riemann's sum. But one more note before we start, which is really important. This is Riemann's sum, and not this, which is really important. Like this, okay, yeah, Riemann's sum, but not this. There's a huge difference, because with the limit, it makes a huge difference. Because if you were to do this, let's say, write it on the exam, if you do, let's say you do write this, okay, but then if you end up solving and you don't have a limit, and then your limit pops up out of nowhere, or even without a limit, like you just progress like this, and you end up saying that just somehow substitute by dividing by the coefficients, because we know either way in the end we're going to divide by the coefficients, and you're going to end up with certain numbers, you're going to add them up and you get this, right? But this is due to the limit, so you need to write the limit. But the problem is, if you write the limit from the beginning, it's like a curse. If you start from the beginning, you have to keep on going. But to avoid this, one way I think of it, I think this is pretty much normal to do. One way to avoid this problem of writing the limit in the beginning and continuing, because you have to do limit and then write, then equals limit, then write. If you forget one limit, I mean, they might not be as strict, but still, if you do write one limit, continue. But for this one, I'm gonna do this one trick where I'm not gonna write the limit at the beginning, because I'm equating something to something. I'm not saying Riemann's sum is, no. I'm just immediately going with summation k equals 1 n delta x f of ck. Immediately I'm just saying this value. I'm segmenting the equation. This value is, and then I can continue with the other one. So this is, to save time, I'm going to try doing this quickly. Summation of from k1 till n, and then delta x is 2 over n, into this, which is 4k squared over n squared, plus 12k. You know how to simplify from here, but I'm just gonna do this with you guys. I'm gonna try going quickly, not to waste anyone's time. Here, this is 1 and n, and then this times that, you get 8k. I'll immediately take it out. Actually, no. Actually, let's just 8k squared over n cubic, plus this times that. That's 24k. Yeah, 24k over n squared, plus this times that, that's 10 over n, and then if you split the summations, you end up with k equals 1, here it's n, of 8 outside, n over n cubed outside, you're left with k squared, and then you know your rules with k and all that. So summation of k from 1 till n of k plus 10 over n, summation of 1 from 1 till n. For this one, you'll just end up with 8 into n cubic, or over n cubic, into with the square you end up doing 2n plus 1 into n plus 1 into n over 6. You can cancel 2 here, 2 here. I'm doing this step because I know for sure that I do not care about the 1. I do not care about the 1 here, and do not care about anything else. I only care about what the n powers, because I want the highest power possible, and then from there compare it to this one. So if you multiply the n's, you get n cubic, which is the same power as n cubic over here. So you're gonna do the coefficients of those. The coefficients of n are only visible here and here. So 16 as opposed to 6 over here. This is why I wanted to cancel by 2 here and there. If you cancel by 2 before multiplying, you end up with 3 here, and this cancels. So 8 over 3, immediately the answer is 8 over 3 here for the coefficients, plus 24 over n squared into k. It gives you n into n plus 1 over 2. This cancels that, 12, and then you get n squared, and the coefficient is 12. 12 over 1, you get 12. The answer for this one's 12, plus 10 over n. Then you get here n immediately cancels. You get 10, 12, 8 over 3. Add them up, you get 74 over 3. And did we or did we not get the same exact value as the value over here? We got the same exact value, right? So we know that we're right. And with that we're pretty much done. So in this exercise, we're gonna look for the area again, but this time using again definition, which is what we used earlier. Normally, like, you know, the limit of the summation of f ck times delta x, same thing. It's just that they also want the area of the trapezoid, which is this right over here, which is, you know, half base. In here, if you want numbers, you get 4 plus 12 times 4 minus 1, so that's 4, and you can get the value. If you actually calculate, divide by 2, 4 plus 12, 16, 16 times 2, 32. So our answer is, we're expecting an answer of 32. Again, this is equal to, not similar. We're looking for exact values because we're using the definition with n intervals, not a certain number, so we're not approximating anymore. So this is what it means to look for the area of a trapezoid, or like using the area of trapezoid for this. It's not a modification of the rule, it's just that they're asking you to do two of them, the definition and the area of the trapezoid. I did this first just to show you that we're expecting this. I could have done it in the end to show you the suspense, as in, oh, we can get the same value here. So yeah, you know, as the previous ones, we need to start with delta x, which is b minus a over n. So 4 minus 0 over n, you get 4 over n. And if you want your intervals, that you start from 0, right? So 0 plus 4 over n, you get 4 over n. And then 4 over n again, plus 4 over n, you get 8 over n. And then add 4 over n again, you get 16, sorry, what 16? 12 over n, and so on. So you're going from, never mind. So pretty much to find ck, because I just thought about the normal one with 4 intervals, 5 intervals, but this one is different, it's n intervals. Otherwise I would have continued, so to show you. But anyways, for ck, it's, you have a 0, so 0 plus, so nothing, over n stays constant. Here we're quadrupling, as you can see. So times 4 times 1 is 4, 4 times 2 is 8, 4 times 3, so we're quadrupling k, so 4k. This is actually how to get this. Let me just write it close to each other. So yeah, it's 4k over n. F, although we have that, we only need f of ck. So now f of ck, just put that up. It's 8k over n plus 4, because 2 times this and then plus 4, pretty much. I'm boxing this and this because that's what we need for the summation. So the limit as x, sorry, not x, n, the number of intervals as it approaches plus infinity, we're getting more and more accurate with an absurd number of intervals. It's super small, so you end up literally kind of like adding every single slice of this with extreme precision. So yeah, that's why you end up with the actual area. So yeah, with that times the summation as k goes from 1 till n of f, or we can start with delta x if you want. Delta x times, I usually start with delta x because I know I'll take it out because it's constant. F of ck, it's just a personal choice of writing delta x first. I'm not gonna start with equals immediately. This is my area of, by the way, there's this one thing I forgot to mention. One thing Mr. George said, or he wants to like kind of like recommend us to do, is when you do the area of a triangle, rectangle first, one rectangle, so area of, even for the previous ones by the way, it also works. Area of one, I'll show you why it works. Area of one rectangle so area of one rectangle is f of ck, just that, times delta x. And that's why when you do n rectangles, you actually do summation. That's why, pretty much. So this is nothing odd, and this applies to all the other questions as long as they ask for area and using the summation. This applies to all of them. Area of one rectangle is this, nothing to change. This is ck, f of ck times delta x. And area of n rectangles is the summation of f of ck times delta x, as k goes from this to this. And towards the end we want the limit, so if you want you can add the limit, or you can just start with this, keep on going, you reach a certain point, and then you're gonna add the limit and then move on with the simplified version and then just finish it off with a limit. Or you can start with the limit in the beginning. So yeah, any is valid, should be valid. If you want to see the book and how it goes about it, because the book is supposed to be the accurate way of solving, like, you know, the correct. Of course it can be very rigid, so sometimes it's weird, but follow how they kind of like express things or say things, not necessarily how they solve. How they solve might be annoying, no need to follow them. Follow what we are doing because it's usually easier, like what the teachers taught you and all that. So yeah, if you do the summation, you're gonna end up with summation of k f of ck is 8k plus 4 and here over n times delta x, which is 4 over n. Actually, let me just write this in a much clearer. So 8k over n plus 4 times 4 over n. Let's split the summation. So first of all, 8k over n times 4 over n, that's 4 times 8, that's 32, right? 32k over n squared. So I'm taking the 32 over n squared out, and I said k, so we're left with k, plus this times that, you get 4 times 4, 16n outside over n, I mean outside, summation, nothing stays, so 1, so k1 till n of 1, summation of 1. And with that, 32 over n squared, the summation for this one will be n into n plus 1 over 2, and yeah, plus 16 over n times n. This is where, if you want, you can introduce the limit, and not x, n, as the number of intervals approach plus infinity, we're more and more accurate. So plus infinity, and the summation, if you want to go like step by step, f of ck times delta x from 1 till n is the limit as n approaches plus infinity, and then we keep on going. So 32 over n squared, just to write it, to copy it down so that I can show you what you can do next immediately, thanks to the limit, basically, because without the limit there are things that you might not want to do. And because you have the limit and you have the value for the n, this is when you actually can cancel normally, because you need to know that never mind actually. But anyways, cancel. So you're left with 16, so your limit of that was actually 16, and then 2 this 16, and then this n makes n squared, and same power, so ratio of coefficients. So this answer 16 to 1, so you get 16, so 16 you get 32. Did we or did we not get the same answer as the trapezoid area? We did, right? So this is why they asked you. They wanted to show you that it works, that you're gonna get the same value if you tried you know, using the trapezoid rule. So yeah, pretty much. Okay, so for this one you need to manipulate the integrals. Each one has its own special things, and you're only given, like, for a function you're only given 2 limits for it, or like 2 integrations, 2 definite integrations. So let's start with part A. Part A is a special case. Well, not exactly so special, but it kind of like a lifesaver when it comes to solving, because it's one of the easiest to solve. Easiest, so save your time from this one. 2 to 2, don't think, it's just same limit, immediately 0. If you want to understand why, I have 3 ways to explain this if I actually forget, or I mean if I remember the 3 ways, because I just thought about them previously. The first one is, for example, graphically. Say you have a graph like this and you want to find the area. You are doing, like, from 2 to 3, for example, let's say like this, you find the area like that. But if you find the area of a point like 2 to 2, which is the point itself, and you end up with a line, lines in math have 0 width and a length. So the area of a line is pretty much 0. They're one-dimensional you know, figures. So with that, you immediately, that's why your answer is 0. Another way to see this is the fact that when you substitute, you know, as in blah 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 and integral, like you got the value of the integral of this somehow, and then you do this from 2 to 2. Either way, you're gonna put 2 minus, and then you're gonna put 2. Same expression, subtracting same expressions gives you 0. You're pretty much done. There was, I promised a third one, but I think they're pretty much the same, I guess, not that much. So yeah, you're basically subtracting the same limit. You're just going from a point to the other. It's just, you're doing, it's like saying 0 work, for example, if you're talking about energy and all those. So you're not really doing anything, just from point to a point, same point, so 0 area. B goes from 2 to 1. I'm gonna take the 2 outside. U of x dx. I don't like how it's 2 to 1, personal preference, so I'm gonna change it to 1 to 2. Makes things easier also when you want to see it visually, for example. So minus 2, open brackets. For this part, I have a graphical or a visual representation. So if you have, let's say, the number line like this, this is 1, this is 2, this is 0. So if you want to cross the path from 1 to 2, so you want to go like this, right? But you don't have 1 to 2, you have 0 to 1, you have 0 to 2. So another way, ignoring this, by the way, ignoring them, another way to see this is to go like this, and then like this. The green is an alternative to the red, because this will cancel with this, you end up with this. And you know, like displacement and all that, you will end up with this initial, same initial in both, and also same final in both. So yeah, pretty much. So for this one, it's integral from 1 to 0, important, so you're going from 1 to 0, and then integral from 0 to 2. So let's write that. So integral from 1 to 0 of, let me change the color, let me pick purple, for example. Integral from 1 to 0 u of x dx plus integral from 0 to 2 u of x dx. Minus 2. By the way, I put the brackets earlier because I knew that I'm going to split it into a plus. And of course, if you want to distribute, you will do that, but keep in mind you have a plus, so minus minus in both, like minus here, minus there. So yeah, integral. Do we have 1 to 0? No, we have 0 to 1. So you flip. These small processes make a difference. So that's why I'm doing everything slowly, very slowly, because swapping limits is nothing important. It's really trivial, but it's nothing to underestimate also when doing like mistakes. So now do we have what we want? So we're going, let's read it like this. We're going from 0 to 1. So 0 to 1, and then add, and then negative of that. So you reverse, and then you add to it from 0 to 2. So you get this. So you get this in the end, and then you subtract. You multiply by minus, and you multiply by 2, because that's what they have. They want. They give you 2 to 1. So 1 to 2, again negative, and 2 times because they have 2. So we reached what we want. Just substitute for this one. Minus 2 into minus from 0 to 1, 2. Plus from 0 to 2, minus 1. So minus 2 minus 1 minus 3 times minus 2, you end up with 6. Pretty much. Now for the last and final one, for this one, C. Let's pick, for example, dark blue. C. For this one, you just from 0 to 2. Thankfully, this time you are looking from 0 to 2, and you have explicitly written here, so you don't have to go through this mess again for at least the U part. For the V, from 0 to 2, thankfully you're given from 0 to 1, and from 1 to 2. Just add the 2, you end up from 0 to 2. So not like this, where you have to reform. There might be an easier way, by the way. I'm just showing you how you can go step by step, making 0 mistakes. So yeah, so integral from 0 to 2, I'm splitting it already, if you don't mind. So 2 over 3 into from 0 to 2 to of ux dx plus 1 over 2 integral from 0 to 2 v of x dx. So this is 2 over 3 from 0 to 2. We already have this to be minus 1. So minus 1 plus half of. If you want to see the slow steps, fine, I don't mind. So from 0 to 2, it's from 0 to 1 and 1 to 2. So 0 to 1 of vx dx plus from 1 to 2 vx dx. And we are nearing the end. If you want to save time or space, actually, this 0 to 1 is exactly the same over there. So this is, actually, if you want, let me write, no need. So yeah, minus times this, so minus 2 over 3 plus half into, this is where we simplify. So from 0 to 2, 0 to 1, 0 to 1, 2 over 3 plus 1 to 2 minus 2. So here it's actually minus 2, because plus minus, I don't want to write the plus, so minus 2. If you do the calculation, you get 2 over 3 minus 2, you get minus 4 over 3 times half, and plus, or actually minus, because you have a minus, 2 over 3. You get minus 4 minus 4 over 3. Final answer for the limit. And you're pretty much done for this question.
Hey guys, so this is 5.3. So we'll start off with the section beginning. So the average value of f of x. So for average value, what you need to do is, what it basically means is the area divided by the width. So for example, you have these few points, you have these few graphs over here. The first one is just a straight line. So the average value will obviously be the value over here, the y value over here. Let's say it's a. For this straight line over here, where it's not horizontal and it slopes up, the average value, will be at a midpoint over here. Why? because it's basically going up in the same, like every 2 or sloping up every 3 units, and you have a straight line and you just take the average of it, so it's pretty simple. And then for the next one, where you have a graph of, let's say, I think it's like x squared plus 2 or x squared plus 3, you can see that it spends most of its time over here in the bottom. So instead of being at the middle, it will be somewhere over here. The y value will be corresponding with somewhere over here, which might be a little over the actual starting point, because it spends a lot of its width down here. So even with this high value at the end, it will contribute, but it will, because it wasn't like a straight line here, it will actually lower this, because it spends most of its time at a lower y value. So the next one, so we'll take a few examples here. X squared plus 5. So the formula for the average value is integral from a to b of f of x, and that basically means you find the area under the graph over here. Then you divide by the width, so b minus a. So this is a, and this is b. So b minus a is the width. So then you'd find the average y value in terms of the area, you know. So if we were to do this mathematically, integral of 0 to 3 x squared plus 5. So you can just enter that on your calculator, or you can solve it, you know, mentally. So it'll be x cubed over 3 plus 5x, and then this function from 0 and 3. So the answer becomes equivalent to 9 plus 15, which is 24. So 24, that's the area. So to find f average, you divide the area by the width. So it will be 24 divided by 3 minus 0, which is equal to 8. And that is the average value. Next one. So this is the next point of section 5.3, the mean value theorem. For a definite integral extending from a to b or any point, there always exists one value, x equals c, such that f average equals f of c. And obviously this is for continuous functions, because if it wasn't continuous, then there might have been a gap. Like let's say instead of this point, it just goes up here, and then down here with a gap. So obviously you wouldn't have that value, so you couldn't say. So it has to be continuous. So you do it as regular. You find the f average like last time, integral divide by width, and then f of c. That is where the additional point comes in. You have the function inside the integral, and you simply equate it to f average, and you can find out what c is. And to get the y value of c, you simply substitute it in, and you'll get it, which is the f average, by the way. So here we have an example. F of x of equal to 3x squared plus 2. Find f average. So integral, do it in a different color. Integral, they have to give a parameter, like an interval. So let's say from 0 to 3, like last time. Integral of 0 to 3 of 3x squared plus 2x dx. Then you just solve a normal integral. 3x squared is x cubed over 3 times 3, so it just becomes x cubed, and then plus 2x, plus 2, and then becomes plus 2x, and then from 0 to 3. So this is equivalent to 3 cubed, which is 27, plus 2 times 3, which is 6. So 27 plus 6 is 33. And then minus 0 cubed plus 2 times 0, so 0. So it is 33. Now that is the area. F average is equal to the area over the width. So b minus a, 3 minus 0. which is equal to 11. Now you need to find the x value, which is c, such that the f average that we got, which is 11, is equal to f of x, or f of c. So if you simply equate it, 3x squared, or actually let me put that as c, 3c squared, because this is f of c, f of c equals 3c squared plus 2, which is equal to f average equal 11. So 3c squared plus 2 equal 11, and then you end up with c equaling plus or minus 11 minus 2, which is 9, and then you divide it by 3, because 3, you get 3, so plus or minus root 3. But notice that they said that c is a value in between the interval, so between 0 and 3. So it's not negative, and it's simply plus root 3, and that is the value of c. Okay, so continuing with 5.3, first fundamental theorem of calculus. So this basically implies, or this states, that for the integral of f of t, where you have a parameter from a to u can be anything from, it can be like x, or it can be x squared, but I used u instead of x, so you know what to do when you have something that whose derivative is not 1. So it states that for an integral of f of t dt, it's equal to the derivative of that is equal to the function but of u. But remember, this a is a constant. It has to be a constant, and then its derivative is equal to function times the derivative of u. So let's say you have this function, and then d of this is 2t plus 3, but this is a constant, so you're good, and then x power 4. So you just sub in x power 4, so 2x4, as in this was t before, and then 2x power 4 plus 3 as regular, and then you multiply by the derivative. It has sort of a similar appearance of chain rule. If you consider this to be the exponent, then you have this as a derivative. It's not mathematically similar, but you can memorize it, or you can understand it, or have the ease of memorizing it that way. Now let's do an example. So here we have a function, and then we are asked to find the derivative of an integral. So it is a function itself, but what do we substitute for t? Obviously, from the first fundamental theorem of calculus, you have to have a in the bottom, the constant in the bottom, but this is u, and that is a 4. So you put a minus for the answer, because you need to flip it. So then it becomes minus integral of 4, and then x cubed, and then root 1 plus s sine t in dt. Okay. So now you put it in the proper way, it's a minus, and then all you have to do, according to the first fundamental theorem of calculus, is just plug x cubed in, and the constant doesn't matter. So it becomes root 1 plus sine, and then t is, you just put in the x cubed, this value, x cubed, and then you multiply by the derivative of x cubed, which is 3x squared. That's the answer for that. So minus root 1 plus sine x cubed, and then outside the root 3x squared. Next one, the secant from x to x squared. Here you have to apply the first fundamental theorem of calculus, but you have an integral that is not a constant, so you basically have to separate it into a constant. So you equate this into integral of x and x to 0 and then secant t dt plus, actually not 0, make it any constant a such that it's between x and x squared. You'll see that it cancels out, so it doesn't really matter whatever you put in there. And then this becomes x squared plus, by the way, plus x squared and a as well, and then secant dt. Basically, you're just separating it. Here you have x squared, so you're fine, but here you're not fine because you need the constant to be the lower bound of your integral. So you put a minus. So it becomes minus because you want to flip the x up. You want to put the upper bound. Minus secant x and then plus secant, and then you plug in the upper bound because it's a constant. The lower bound is a constant. Minus plus secant x squared. So if you want, you can simplify this and you'll get the same answer, and it'll probably be one of the choices for multiple, or written in this case because the periodic is written. Next one, the second fundamental theorem of calculus. This is basically very simple. It's what we did. So it basically defines what a definite integral is. So if you have a function f of x, which is the integral of the small function f of x without any bounds, so you're going to have plus c, then integral of the definite integral with bounds a and b of f of x is equal to the capital F of b minus capital F of a. So this is basically defining the definite integral, and it's what we've been doing the whole time. Or you just enter it into a calculator, you'll get the same result. So this is basically the definition of a definite integral, and what you do with the lower and upper bounds. So it's pretty much that's it. Nothing too hard. So let's move on. So we'll just do regular integral. So this is a pretty hard one if you're not given the clue that is here. If you're not given the clue. So sine squared x, normally for let's say a variable squared, you would just put it, make it add 1, then divide by it. So like x squared becomes x cubed over 3. But this is sine. You have to divide by the derivative, which is cosine. And then once you do that, you'll end up with x again, and it won't really work out. So what do? You need to figure out a way to get rid of the squared. And then we know, or it won't come to your memory because this is a bit complex, or it's not complex, but it won't just come to your memory or come to anyone's memory unless you have been properly immersed in the subject. So cosine 2x equals cosine squared x minus sine squared x. It's identity. That's how you solve this question. And then cosine squared minus sine squared. Cosine squared is 1 minus sine squared, and then you add minus sine squared again. So it becomes 1 minus 2 sine squared. Then sine squared, once you just shuffle things around, so cosine 2x equals minus 1. Cosine 2x minus 1 equals minus 2 sine x squared x. You divide by minus 2, and then you get this formula. So once you do, you just substitute, so it becomes integral, b and a, I won't repeat it, of 1 over 2 minus cosine 2x over 2, then dx. Here, now you just do a simple derivative, integral. So half becomes half x, and then minus cosine 2x becomes, since it's cosine and you're doing integral, so minus cosine, integral is minus sine, so it becomes minus sine 2x, and then you divide by the coefficient of a, so over 2, and then you have this 2 as well, so times 2, from pi over 2 to pi over 4. You just plug it into the calculator and you get the answer. Obviously pi over 2 you plug in, and then minus whatever you plug in with pi over 4, whatever the answer you get, and you get the answer. Next one, cosecant squared. Here you might not know what to do immediately, obviously you have to think back to a previous identity. So for cotangent, it's equal to cotangent of ax is the derivative, so y prime is equal to cosecant squared minus a cosecant squared. I'll make it better. If y equals cotangent ax, then y prime equals minus a cosecant squared ax. And you don't have to worry about a now because it's x, it doesn't have any coefficient. But if you did, then you would simply divide by it. So minus cosecant squared is the derivative of cotangent is minus cosecant squared. So therefore, the antiderivative, the opposite derivative of cosecant squared is minus cotangent. Always the minus, it just flips between them. If you have a positive, the other becomes minus. So then the integral becomes minus cotangent bounded by minus cotangent bounded by pi over 4 and pi over 6. So then you take your calculator out, you do minus 1 over tangent x, sorry not x, pi over 4 minus 1 over tangent pi over 6. Remember to keep it in radians, the calculator in radians. So this is pi over 4, it's minus 1 over 1, and then tangent pi over 6, it's 30 degrees, so sine is half, and then cosine is root 3 over 2, so it becomes 1 over root 3. So minus 1 over root 3, so this becomes positive, and root 3. So the answer is root 3 minus 1 for this whole question. Next up, we have substitution. This is pretty easy. It's what we did again. We're just restating it. So if you have something, if you have a function and you want to simplify it, you can just take a equation that's really messing with the integral and just make it u, and then divide by the derivative of that u, which is u prime. And then this is how you convert dx to du. And obviously u is in terms of x, so that's why you can't just take it out, otherwise it would be a constant. Obviously just divide by derivative. So an example, cosine x cubed sine x. So in these exams they'll give you sine x, or they won't give you sine, but they'll have sine x in the function. So when you divide by the derivative, it will be very simple for you. So it will cancel out perfectly in that. So u equals cosine x, du of dx equals to minus sine x, the derivative. So if you can't mathematically do this, but you can do it for visualization. So du then becomes minus sine x dx. So here you have sine x dx. So you can't, you can just take it away, but you need the minus. So then it becomes integral of minus u cubed du, and then the bounds you put cosine, it's u, so you just substitute these in. So cosine pi over 3, it will be cosine 60, so half. Then cosine 0, it will be 1. So this then becomes minus u power 4 over 4 of half and 1. And then you put it in the calculator, and you should get a value. It will be a fraction, and it will be of order 16, or yeah, it will be of order 16. So something over 16. And that's it for this question. Now, last question before we move on to the grid that Ali Tabaza will do. Over here. This is what's causing the problem. You can't just put the x in, or you can't just get rid of the... You can put the x in if you make it x squared, but then you still have a problem with the radical. So let u equals x squared plus 4. Let du over dx, let's say, I'm putting it dotted so you can see it later. That doesn't visualize it, so I'll just move it. And then derivative 2x dx. Here you have x dx, so you need a 2. So the 2 becomes a half. Why is it in the denominator? Because you divide by the derivative, or you need a derivative. So let's say it's you multiply by 1, so it'll become 2 over 2. And then the 2x will go for u, 2x, the 2 will go up, and then half remains. So at the end, you're left with integral of half, let's just move it outside, root u du. And then you change the bounds. So x squared plus 4. So 3 squared plus 4 is 9 plus 4, 13. And 0 plus 4 is 4. Now, integral of root u. U is just a variable like x now. You don't have to treat it differently. That's because you changed the bounds. Otherwise, you'd have to put the x squared plus 4 back in if you didn't change the bounds, but you did. So, root u is u power half. Now, integral, you just add 1. So, half plus 1 is 3 over 2. And then you divide by the new power you got. So, 3 over 2. So, it becomes multiplied by 2 over 3. So, 2 over 3 into u power 3 over 2. That's a wonky 3. 3 over 2. And then the bounds, 13 over 4. And don't forget the half from outside. So these cancel. So it just becomes 1 over 3. So now, 1 over 3 of root 13 cubed minus 1 over 3 of root 4 cubed. Put that in the calculator, you'll get it. Or if they ask for a simplified version, you just expand it. Expand the 13 cubed, check for any factors. There's a function on the calculator, I think it's in ENG or F fact. It's fact, it's like factorial. Sorry, not ENG. Factorial. Once you press it, then it will give you factors. And then 4 cubed, it's pretty simple. It's you just take multiply, or you don't multiply, it's 2 times 2. So 2 goes out. So 2 goes out 3 times, so it becomes 8. So minus 8 over 3. And that's it.
Here you can do the absolute value to guarantee that the areas you're going to get is positive, or you can just do minus because you realize that if you sketch it, quickly sketch it, like how I'm doing, and it will be minus 1 down, and it's going to be like this. So it's going to be from 0 to 1, so your area is negative, and so just immediately minus of the integral from 0 to 1, which is nothing but the integral of from 1 to 0, yeah, and you can do it that way, of x squared minus 1 dx. For here I'm going to swap, and I'm going to immediately integrate, so to power 3 over 3 minus x, and as I said, I'm going to swap, so it's going to be 1 to 0, just to remove the minus, and yeah, substitute. Here you're going to get 0, minus, I am sure that I'm going to get minus here, but let's do it. Put 1, so 1 over 3, minus 1, and this is where you get your minus. It's actually minus 2 over 3, minus gives you 2 over 3. Let me double check, yeah, that's the right answer, 2 over 3. So for this one, a quick sketch will not harm, just to figure out if we have to split areas or anything. And it's minus x plus 1, so plus 1, and it's minus x, so it's negatively sloping. These points are going to be 1 and 1. Like here, it's going to be 1, 0, here it's going to be 0, 1. I'm not going to bother writing it, but yeah, anyways. From 1, oh, y-axis. we're not integrating with respect to x, we're integrating with respect to y, from y to y. So from 1 to 1, from 1 to 3, yeah, from 1 to 3, the area is negative, because in the x sense, it's above the x or below the sense, below the x. For the y, it's above the y, or like to the right of y, or to the left of y. This is what means negative or positive. So yeah, so I'm gonna do minus. So minus integral from 1 to 3. We're gonna have to play around with the function. Take minus 1, take 1 to the other side, so minus 1 and minus x. Or actually, immediately you can just do take here this, take that there. So it's gonna be x equals to 1 minus y, faster. And so 1 minus y dy, and we have our limits, we have our bounds, or so I'm gonna swap them and integrate immediately. So here is y, I got used to x. Here's y minus y squared over 2, and oh yeah, I just noticed my music is off. Anyways, 3 to 1, I'm swapping the limits, and yeah, so 1 minus 1 over 2, right, this is 2, and minus 3, so 3 minus 9 over 2, because 3 squared is 9, so 9 over 2. And this is nothing but half minus, if you do this quickly, you're gonna get 6, so minus 3 over 2, I think. I'm doing this quickly, mentally. Let's double check. 3 minus 9 over 2. Yeah, you get minus 3 over 2. So you're gonna get minus minus, you're gonna get plus, you're gonna get 2 here. Because half plus 3 over 2. So basically, 0.5 plus 1.5, that's 2. So for number 3, a graph would be nice. So I got us a graph ready. I mean, it's not the graph itself, it's the plot. And yeah, so let's graph. I'm gonna care about the y-intercept and basically when x is 0 and the corner point. These are easiest for me. So yeah, so when is y, like when x is 0, so put 0, so 0 minus 2, you get minus 2, absolute value of minus 2, you get 2, 2, minus 1, you get 1. So our answer is y equals 1 when x equals 0. So that's the y-intercept, 0, 1. Anyways, corner point, yeah, right. Corner point, it's basically if you have x minus a, it's gonna be a. I am disregarding the fact that you could have a coefficient here. I think in the last clip I said exponent by mistake, so yeah, I meant coefficient. Anyways, and here minus 1 or plus 1 or any number you have, it's gonna shift it up or down wherever the, what do you call it, the corner point is, it's just gonna go up or down. So it's gonna be x minus a, it's x equals to a. So if you have x plus some number, it's gonna be x equals minus 2, negation of that. So yeah, it's gonna be at 2. It's not gonna be here, it's gonna be anywhere within here. So let's know where exactly. Actually, the point's here, but let's know why. So let's put 2, x equals 2, right? So 2 minus 2, you get 0. 0 minus 1, you get minus 1. This is why it's here. So let's erase this and do things right. We know that x is 2. When x is 2, y is minus 1. So it's here. This is the corner point. Why the corner point? Because it makes things really easy, to be honest, and for the graph of absolute value. Because once you know the corner point and you know how one side looks like, symmetrically the other side will be really, really easy. Also, I'm focusing on the fact on how it's looking like it got some of the scaling wrong. This is why it looks weird. But anyways, I did that just to show you that this triangle is in fact equal to that triangle, equal to that triangle, equal to that triangle. Just excuse my drawing a bit, I guess. So because they're equal mathematically, I can take the area of one of them, multiply it by 4 to get the rest. So you don't need to do the solution in the paper, which I think they did for every single integral, for every single side. No need. Just area equals 4 times, this thing is being slow. Anyways, 4 times the integral of from 0 to 1, or pick any of them. If you want, I'm gonna pick the positive. It's gonna make things easier for me. Let's pick here. It's from 3 to 4. One disadvantage is we don't have a 0, so we can't cancel immediately. But yeah, عادي. It's quick math. So if it's positive, we keep the same slope. So it's gonna be this. How do we double check? When does it hit the y-axis? When y is 3. I mean, when does it hit the y-axis? When y is 3, which is actually the case here, x minus 3. So yeah, for this one, if you take this one, for example, if you want the area of this one times 4, you're gonna do the negation of this, whatever is in the absolute value is negated, not this. This is left untouched. So it's going to be minus x plus 2 minus 1, so it's going to give you minus x plus 1, which is justified because minus x means negative slope with slope of 1, and plus 1, so it's going to pass through this point. See, things align, so it makes sense. But I'm picking this because I don't like the negation, I guess. But actually, no, we just did it, right? Yeah, so I'm going to use that. So from 0 to 1, we're going to use this slope. So minus x plus 1. Really easy, we just used it, we just proved it. So let's use it. So 4 times the integral, so we integrate, so minus x squared over 2 plus x from 0 to 1. Things cancel up neatly. 0, I mean, immediately there are x's everywhere, so zeros. So minus half plus 1, right? Yeah, so you're gonna get here half, you're gonna multiply, you're gonna get 2. And I think in the sheet they do half plus half plus half plus, they're the same area, no need, just multiply by 4. And yeah, okay, so for number 4, wait, is it the one I don't like? No, I think it's some other question. Anyways, so let's do a quick graph. Okay, I have a really weird song playing in the background, but anyways, x, y. Oh, by the way, for this one and these ones and these kind of ones, when you have shifts to the right is when you have minus, shifts to the left is when you have plus. This is a shift to the left with 1 unit. Sounds counterintuitive or opposite to or reverse logic, basically. Why? Because say that you have x plus 1 equals to 0. Do you say x is 1 or do you say x is minus 1? X is minus 1. This is the counter logic that we just mentioned. This is why it's opposite. So when you see plus, it's shift to the left by 1 unit, so it's here. And this is parabola, there's no plus or minus, so outside, I mean, the expression with the square expression. So it's just this immediately, no ups or downs. I'm not bothered to write the equation, so I'm just going to leave this. X plus 2, so here it's 1, let's double check. When x is 0, what's y? Put 0, you get 0 plus 1, 1 squared is 1, so yeah, this is 1. This is x plus 2, so here you have 2. Slope of 1, which is somewhere like this. This should be, I mean, graphically, if my graph is neat, this should be 2. I mean, minus 2. So minus 1. Let's double check. What is x when y is 0? Put 0 here. You're gonna logically see that this is minus 2. So we're right, minus 2. And this point, is it 1? I think it's 1. Put 1. 1 plus 2. No, is it 2? No. We can solve it, I mean. Well, actually, it doesn't matter. It doesn't matter. Why? Because here is x minus 1, which is what they're asking for here, minus 1, and y-axis. So let me pick a new color. Let's pick blue. So we want this line, the area bound by this line here, satisfied. Y-axis, okay, satisfied. X plus 2, we can start to see the area. I mean, you can see it by now, so I don't have to do it slowly, but yeah. So this is the area. So just immediately let's integrate. Let's pick purple. So area is the integral from, by the way, we have to know, do we have to split it? Here it's the same, up is the same, down is the same, nothing's changing. So we can immediately integrate with the difference, of course, this minus this. So from minus 1 till 0. So minus 1 till 0. And up is what? Up is the line. So x plus 2 minus the parabola. So x plus 1 squared dx equals, we're going to move the graph. Some things are oh, what the hell? Anyways, I'm just going to delete this, actually, if you don't mind. You can watch the video, reset if you want to see the graph again, because it died. Anyways, so integral from minus 1 to 0, so it's x plus 2 minus, do this quickly, so x squared plus 2x plus 1 dx, again, integral from minus 1 to 0, x, I'm doing this step by step, minus x squared, not to do a mistake like last time, minus 2x minus 1 dx. By last time I mean with myself, not this question, some other question, but anyways. Yeah, let's not integrate immediately. So minus x squared, I'm taking in ascending or descending order because I like it that way. Minus 2x, and x, so it's going to be minus x, plus 2, and minus 1, so it's going to be plus 1, and dx, right? Anyways, ignore if I did a mistake, slight mistake. Anyways, you can always, guys, double check and stuff, but this is just for the concept. And yeah, so minus x power 3 over 3 minus x squared over 2 plus x. So guys, be confident in your way of solving. So if I do mistake, it's fine. It happens. So from zeros, it's just gonna cancel. You get 0. 0 is minus 1. It's just gonna be, I mean, technically I hate doing this, but substituting here. So it's just gonna be minus 1 minus, it's gonna cancel. So 1 over 3 minus, this is square. The minus gets removed, so 1 over 2, and the minus remains, and here minus 1. I can do this mentally, but yani, just double check. 1 over 3 minus 1 over 2 minus 1, you're gonna get minus 7 over 6 times minus, you're gonna get 7 over 6. I just double checked, it's the right answer. So yeah. Okay, so number 5. Okay, let's grab this. I think I need a 3 and a 1. So I think I need to do this. I think. Because we have a huge positive side here. And it's going to be shifted here. So let's say this is 1. So the parabola is going to be like this. We just discussed it above. You know, because left shift by 1 and there's no up down. So it's going to be like this. I'm not going to be bothered to write the equation. So let's leave it like that. Let's do it like this. I'm going to say that y is huge. Like this is, say, 1, this is 2, this is 3, this is 4, this is 5. So this is why I made it slower. So this is gonna look funnier here. Anyways, yeah, ignore the asymmetric shape or whatever it's called. Anyways, this is 4, so 1, 2, 3, 4. Yeah. I think this goes way beyond, because I think this is 1. No, this is 1. And let's double check. So this is when it hits the y-axis when x is 0. So 0, you're gonna get 1. So this is 1, as we just proved it. And this is 4. So when it hits here, and where is this point? It's when y is 4, which is when x is 1, right? Because if you put 1, you get 1 plus 1. That's 2. 2 squared. That's 4. So yeah, this is 1. Oh, it goes really fast. Anyways, we got 4 and we got x equals to 3. So this is the far one. Let's just imagine somehow this is 3. I should have done it. Anyways, so this is 3. I should have compressed them a bit. So this is 3, for example. Just let's imagine. Of course not, but yeah, let's imagine. So you're gonna have 2 areas. You're gonna have from... Oh, this is the one I didn't like, yeah. Because it was impossible that all 4 of them are bound, like have an area in common. So it's actually 3 by 3. So 3 of them have it bound and 3 others have it bound. So y equals 4, the y-axis and the parabola. Y equals 4, x equals to 3, and the parabola. These are actually the bound areas, apparently. And yeah, because when I read it, I was like, okay, this, and that. So anyways, if they want to do it that way, let's do it that way. So we have 2 different areas. If you take this to be the center, I guess. No, never mind. I was gonna say negative and positive, but we don't care. It's up minus down, up minus down. Yani even if you, let's say you have an area like this and you're doing it like that, and you have an area somehow, let's here. This is negative because if actually you do 0 minus this is why. Yeah, now I know. So it's up minus down. You don't actually care if it's negative or positive. Up minus down. This rule applies for everything. Up minus down. So area equals, here you start up by 4. First of all, what are our bounds? What's the limits? From 0 to 1. So 0 to 1, up is 4. 4 minus, what's down? The x plus 1 squared dx. I want to find a way I can do this super quickly. 1, 2, 3, just save time. And here we have this time the quadratic function up, minus 4 dx. I mean, if you do this, you're gonna get, what number is this? You're gonna get 37 over 3, but let's do this quickly, I guess, if I can find a way to do this quickly. So if you integrate here, you're gonna get integral from 0 to 1. I mean, before integration, actually, this is annoying me, this is why. Anyways, yeah, so integral from 0 to 1, and this is 4 minus that, you're gonna get 4 minus, I'm gonna do this quickly, squared minus 2x minus 1 dx, I hope I did nothing wrong, plus integral from 1 to 3 of x squared plus 2x plus 1 minus 4 minus 3 dx, integration immediately. So oh yeah, if you subtract these two, so 4 minus 1 is minus 3, no, 4 minus 1 is plus 3, yeah, this is minus 3. So you get equal to minus x to the power of 3 over 3 minus 2x, well, if the 2's cancel, wait, let me just, anyways, over 3, so minus 2x to the power of 2 over 2, so that's x squared, plus 3x. I cancel the 2's. And here from 0 to 1, plus x to the power of 3 over 3, again cancel the 2's, 2 over 2, minus 3x from 1 to 3. If we do this quickly, zeros here, 1, so minus 1 over 3, because I plus, put the zeros first, because the zeros are easy. Minus 1 plus 3. And this gives you minus 4 over 3. Minus 4 over 3 plus 3 gives you 5 over 3. So this gives you 5 over 3. This is kind of like the way I do it actually. And this is 3 with 3 cancels, you get here 9, 3 times 3. Plus, I'm doing it mentally just to show you the calculation, because sometimes some of us do the calculations wrong and like, where did we go wrong and stuff. So minus 9, 9 cancels, 9. So this is the first part. Minus 1, so 1 over 3, plus 1 minus 3. This is 4 over 3, minus 3, that's minus 5 over 3, so plus 5 over 3 with the minus, so this is plus 5 over 3, so 9 plus that, here you get 32 over what? Over 3, if you add these two, and add these two, you can already see that there's 37 over 3, 5 plus 20, 32, we get that, so 37 over 3. So we're doing number 6, and yeah, so let's put the graph like that, and this is x, this is y. So when x is 0, y is 0. When x is minus 2, y is also 0. So we have the point 0, 0 and minus 2, 0. So 0, 0, and let's say this is minus 1, so this is minus 2. So we said minus 2, 0. So we're gonna have, because if it's gonna be here and symmetric, so this is gonna be where the point is. So let's find, so we know x is minus 1. If you square it, like if you distribute, you're gonna get x squared plus 2x equals to y. We want to put minus 1 to find where is it exactly here. So put minus 1, you're gonna get 1 minus 2. So you're gonna get minus 1. As expected, it's actually 1 unit away. Yeah, so minus 1. I'm not really good at drawing parabolas, but I think this is how we do it. Yeah, kind of. One thing I know is just it goes slow here, but then it goes fast. Anyways, maybe I can fix this like this. Cheating, but yeah. Anyways, this is why you need to draw digitally. It's much easier. I mean, I'm drawing with a mouse, so it's horrible anyways. Yeah, so from minus 2 to 0, so that's what I only care about. And it's also y equals to x. So y equals to x, here is going to be low. You can double check using substitution, and it passes through here. This is the benefits of a nice drawing. You don't have to calculate sometimes. But anyways, so you can always double check. So we are saying that it passes through this point. So let's double check. Put minus 1. You get y equals minus 1. So it's the same thing. Again, it passes. So anyways, so this way we just saw that from minus 2 to 0, which is from this minus 2 to 0, we are getting this area and this area. Here there's a top, there's a bottom, there's a top, there's a bottom that's different every single time. So we cannot integrate constantly, immediately from 0 to, minus to 0. No, we have to break and split. I need space, so I'm gonna erase this. I might even erase the graph, but I'm gonna remember, or I can scale it down actually. If I need space, delete like this, like magic, scale it down. Now it looks cute. Anyways, I'm gonna change the pen. Let's put red. Also the music is nice. Anyways, 6, you guys don't hear it. Yeah, so for integration from -2 to -1. And which one's up? Up is the parabola. So we said this is x squared plus 2x. For simplicity, not every time to look here and do it. So x squared plus 2x minus the one down, which is minus x. So it's gonna evaluate to x. I was gonna say evolve, anyways. Dx plus integral from -1 to 0 of up is what? The line. So x minus x squared minus 2x, because the minus distributes. Minus and plus, the minus is bigger actually, so the minus survives. So it's x minus x, because x minus 2x, it's x minus x. So dx equals, oh, did I just put twice? Dx equals, let's do it step by step. No, actually we can integrate immediately. X to the power of 3 over 3 plus x to the power of 2 over 2 from, also my notation looks weird, but I don't know if it's actually correct or not. I see some people doing it, some people don't. Anyways, minus x squared, minus x to the power of 3 over 3 minus x squared over 2 from -1, from -1 to 0. This is the annoying part. We have to substitute. I mean, you can do it, or I can just immediately tell you, wait, which number is this? 6, so the answer is 1, so let's double check. So we're supposed to get 1. You can stop here immediately, because if you know everything is right, you know it's right, but you can keep on going. Let's solve this together. Some of us, even it happens to me, we get the wrong answers because we substitute the wrong things, or we do wrong calculations. Sometimes we do it mental, so yeah. So yeah, let's put -1. -1, the minus sign stays, so -1 over 3. -1 here goes and becomes 1, so 1 over 2. Minus square brackets. Oh, no need, because there's not a minus and stuff. Anyways, so put -2. So it's -8, because 2 cubed, over 3, plus the minus goes away, 4 over 2, which is 2, plus zeros make zeros, and minus -1 becomes 1, so 1 over 3. Minus stays. Minus here goes, but there's a minus here already, so 1 over 2. This is nothing but 1 over 6, and minus 1 over 6 to be no, this is minus half. The half is bigger, so it's minus half. The minus with the minus makes a plus, so all of this evaluates into 1 over 6. If you saw this was too fast, you can always replay back and solve it yourself. You're gonna find it to be that way. If I did a mistake, I apologize, but yeah. So 2 minus 8 over 3, you get minus 2 over 3. With a minus here, it becomes plus 2 over 3. And so you have this 2 over 3 plus 1 over 6. You get 5 over 6. So this plus that, you get 5 over 6. Let's simplify. Minus a third plus a half, you get 1 over 6. 1 over 6 plus 5 over 6, you get 1. Is that the answer? Yes, it is. My aiming is bad, but yeah, this is it. So number 7. Thank God we have the graph, so we don't have to graph, which you can just immediately notice. And it's accurate, so just immediately this is 1, 2. This is lagging. And it's 2. And we can figure this out. I mean, by ratios, we can technically say this is, well, not technically it is, but you know, half, or 1 over 2. And this looks like half of a half, so it looks like 1 over 4. So technically we could just integrate immediately. But always double checking is nice, because sometimes it's not to scale. But usually not to scale like this, but not to scale, yani it wouldn't be inaccurate. But yani it's always nice to double check. So what is this point? It's the intersection between this line, this one over here, and this line over here. which is a horizontal line. So horizontal line, so y equals 1. So 1 equals 2x. So x is half, just as we said, the thing is lagging. Anyways, so you get half. And for the other one, it's just the intersection of this with this. So 2 square root of x, just to show you how to solve it. Intersection with the horizontal, so 1. So square root of x equals to half. Again, it's lagging. Half? Yeah. Yeah. And then square root, so square this to get rid of the square root, so 1 over 4. And this is actually how we got the points. So anyways, it might have been a waste of time, but you know, always wanted to double check. So the area now, this time with respect to x for A. So with respect to x, we have a change of up and down, so we have to split the integrals. So first integral from 1 over 4 to 1 over 2. So area equals, I just like writing it. And yeah, integral from what's up? Up is 2 radical x minus what's down? Down is 1 horizontal line dx plus the integral from 1 over 2 to 1. What's up? Again, same equation, but down changed. This is why we needed to split. Just one simple change, but it's still necessary to split. I mean, it destroys everything if you keep on going without splitting. Dx. And yeah, so this can be integrated immediately. This is x to the power of half. So you add 1, it becomes x to the power of 3 over 2. And divide by 2 over 3. I mean, you divide by 3 over 2, which is the exponent, but which is same thing as times 2 over 3. Times 2, so it becomes 4. This is the 2. So 2 times 2 over 3. Minus x. This is me integrating. 1 over 4 to 1 over 2. Plus, again, same thing, 4 over 3. X to the power of 3 over 2. Minus x squared over 2. 2 cancels. So it's nice sometimes to do things mentally. Sometimes it's faster than a calculator. Sometimes. And it's also nice to train your mind from time to time. This is annoying though. I can kind of do it mentally, like doing this 4 over 3 times. It also sometimes helps with the calculator if you want to type it. You can, instead of typing this and this, you can just type this 4 over 3. It's lagging a bit. This is nothing but x times square root of x, so it's half times the square root of half, so 1 over the square root of 2. You can type it like that in the calculator, minus 0.5 if it's easier for you, minus 4 over 3, 1 over 4 outside, because we said x, and the square root of 4, which is 2, minus 0.25 if you don't do it that way. Same thing as 1 over 4. Yeah, it's easier to, as some people say, crunch it into the calculator or type it in. And this is 1, really easy. So 4 over 3 minus 1, difference of exponents, minus, put the half in. It's the same as this. Copy, no, the other one, copy paste. So let's just not bother and copy it. Making sure, of course, it's correct. So it doesn't hurt to think a bit to double check if it's correct. And yeah, so it's number 7, right? You should get 1 over 6. Let's prove this 1 over 6, or we can leave it. No, actually, let's if you want, let's. It's annoying, but actually, let's just. I really don't care. Wait, what's the answer? 1 over 6, yeah. So 1 over 6. If you do it right, then you do it right. The calculation, it's fine. We can do it in the exam. B. Just with respect to y, it's much nicer. Don't be intimidated with y. It's much nicer with, in this case. Sometimes it's easier with x, but in this case it's much nicer with the y. Look how nice it is. So in this one, from y, from 1 to 2, you get this area because you're integrating kind of like, it depends on how you look. You can look horizontally, you can look vertically, but yani, you're going vertically. So you're integrating like this. If you're doing it with respect to x, you're integrating like this. That's how you're basically going. So you're going like this, with respect to x, with respect to y, you're going like this. So it's going from 1 till 2, and there's one well, in this case you don't say up, you say right and left. Right is positive, left is negative, kind of thing. So which one's bigger? The one on the right, it's bigger than the one on the left. So this one minus that one. I'm tilting my head, so anyways. This is what? This is 2x. So integral from 1 to 2 of 2x. No, this is where you have to mess around with the thing. So y over 2 equals x. You have to get it in terms of y. This is why you're deriving with respect to y, so you have to change things. Here y over 2 equals square root of x. Therefore y squared over 4 equals to x. I did nothing but square. And what's minus what? The line, so y over 2, now in terms of y, minus this, which is to the left. So right minus the one on the left. So y squared over 4 dx. And this is nothing but, let's integrate. So y squared over 4, divided by 2, by the way, if you did not. And this is y cubic over 3 times 4, that's 12. And this is 1 to 2. Also, it's nicer. You can see it's one integration. It's so easy, so nice. No stupid square roots, no nothing. Yeah. And just put here 2 times 2 is 4. 4 over 4 is 1. So 1 minus 2 times 3. 2 to the power of 3 is 8. 8 over 12. You can double check that, but it should cancel 2 over 3. 2 over 3, yeah. Minus 1 over 4. So easy, just put the number and like that. So 1 over 4 minus 1 over 12. You get here 1 over 6. And here you get 1 over 3. Let me double check once. Yeah, you get 1 over 3. 1 over 3 minus 1 over 6. As expected, you get 1 over 6, which is actually what we got here. I deleted it, but yeah, what we got here. So this section is about volumes. This one could be easier. I mean, after all, you're gonna square things, so sometimes it'll cancel. And there's less, oh, is this positive, is this negative? We're talking about volume. We're squaring either way, so yeah. But you have to still split if you see that you're gonna have different curves up and down. Otherwise, you're gonna get, I think, the difference between the two volumes. Like, it's not the answer that you want. Anyway, so one. Okay, so I just care about, okay, we're doing volumes, generated volume, solid, and then x-axis, about the x-axis. So that's just immediately like this, 1 to 2. I mean, it's a difficult function, so I don't think that we're gonna need split, which is, I think, the case. Otherwise you're gonna get some weird number, so you can always double check. But yeah, 1 to 2. Just put the function up here, pi outside, that's the volume. It's pi, the integral from 1 to 2, and the square root of x plus 1 over x to the power of 3 over 2. All of that squared, and yeah, pretty much. So this equals pi. We're gonna do step by step, 1 to 2. Then you're gonna take the square root out, because, I mean, no need for parentheses. X plus 1, because we squared this, and then square this, so the 2 with 2 cancels, so you're going to be left with this. Then there's a simple trick. It's not hard. I mean, some of you, it happened to me. I did 3x squared, and then notes, no, I cannot cancel this with this. So I stopped for a few seconds until I realized, wait, I can distribute. So this is the trick, distribute. Pi, integral from 1 to 2, x over x cubic is going to be x to the power of minus 2, just immediately, so that we can integrate easier, plus x to the power of minus 3, because it's 1 over x cubed, and yeah, dx equals, you can do parentheses if you want, just integrate immediately, add 1, so minus 1, and then divide by the minus 1, so minus, let's not write plus for now, x to the power of minus 2, I added 1, then divide by minus 2, so minus 2, the plus became a minus, and from 1 to 2. I can substitute immediately. This is nothing but 1 over 2, minus 1 over 2, minus 1 over 2x squared, so 2, I think that's 8, yeah, minus 1, minus 1 over 2. Pretty weird, but yeah. So this is minus 1 minus half, so minus 3 over 2 with the minus here becomes plus. And then this is minus half minus, did I do something wrong? Let me just double check. Minus half minus 8. 8 minus 5, no I don't think. Plus 3 over 2. 7 over 8. Oh yeah, it's right, it's right. Also I forgot the pi. Here's pi. Here's pi. It's right. You actually, when you add those two, you're gonna get 7 pi over 8. And yeah. Okay, so this one we're gonna do a quick sketch. Again, for if you, let's say, do these things by experience and stuff, you might not need to graph, but it's always nice to graph. So just to be sure of things, let's just make this clear. Something like this, and this is 2x, and so this is the area. You can always double check. If you put 0.5, this is, first of all, what's this point? This point, try 1. You get here 2 and 2, so this is indeed 1. Otherwise, you just equate if you don't know. And what does it give you? It gives you 2. And so try 0.5 and see which one's higher. Here you get 1. Here you get 2 times 0.5 is nothing but half. So square root of this, because square root of that, the square root of 1 is 1. So yeah. So it's 2 over the square root of 2. If you rationalize, you're gonna get 2 square root of 2 over 2. These cancel, so you get square root of 2. Square root of 2 is like 1.4 something, so it's bigger than 1. So we're right. Whoops, my bad. We're bigger than 1.4 is bigger than 1, so it's higher definitely. You can also check with the calculator. I just did mental math. So anyways, so the volume is pi. Integrating from what point to what point? We said from 0 to 1, and we do, the thing is, we do the function up, or like you could say it like big radius squared minus small radius squared, and radius is basically from the function to the point of, or the line of revolution, and then the lower function minus the, or 2 as in minus to get the length, the line of revolution. So yeah, it's gonna be, what's the one up? It's 2 square root of x minus 0 squared, which is, you know, gonna give you that squared, minus the other one, which is 2x minus 0 squared, which gives you that, and dx. And we just keep on going. I'm gonna erase the graph. This is going to remove, I'll just do this quickly. I mean, it can, yeah, it's fine. Okay, just have to fix this. Anyways, let's go. This is gonna be pi integral from 0 to 1 4x squared minus 4x, this is x, because you remove the square root, it's used, and here it's squared dx equals, let's integrate immediately, pi 2x squared, if you do the x squared then divide by 2, minus x to the power 3 and 4 over 3 from 0 to 1. Let's substitute quickly. This is pi 1 here, so it gives you, oh no, it actually, yeah, okay, fine. 1 minus 4 over 3 minus 0, so the total cancels. Yeah, so it's useless. This is pi. So 1 minus 4 over 3 is going to give you, oh wait, what 1? 2, my bad. I was like, how the hell, you're getting negative. Anyways, so 2 minus 4 over 3, you're going to get 2 over 3, which is actually the answer, 2 pi over 3. So that's a, that was a. So let's do b, which uses the y-axis instead. So about the y-axis, I should have saved that, but anyways, we just had that, it looks like this, and then about the y-axis instead, it's going to be like that. right? So we're gonna revolve like that. So in that case, what you're gonna do is basically the v equals pi integral from, you're gonna do with respect to y, basically, because you cannot like, the line only goes vertical if you use x. The line only goes, so no way it goes back. So you have to use y. So we said here from 0 to 2, because it's actually 0, 0, 1 here and 0, 2. So 0, 2. And with respect to y, so we're gonna have to play around here. So over 2 equals square root of x. Here you get y squared over 4 equals to x. That's the first function. Here is just y over 2 equals to x. Second function. And yeah. So here, which one is to the right? The line is to the right. So it's going to be y over 2 squared minus the other one, which is y squared over 4, which is to the left of it. Again, minus 0. This is why it cancels. Why I'm telling you this? Because some other ones will tell you some other thing other than x-axis or something. Yeah. So dy, again, the right notation, equals pi. Let's get rid of the squares, like as in by simplifying, y squared over 4 minus y to the power 4 over 16 dy equals, let's integrate pi y to the power of 3 times 4, that's 16. Oh, whoops, 12 minus y to the power 4 over 5. I mean 16 times 5, I think 80. Yeah, 80. And from 0 to 2 equals pi. 0 is nice, it cancels everything, so I'm gonna ignore it, and let's just do 2. With 2 is gonna be 2 times, that's 8 over 12. Here 2 over 3. Yeah, 2 over 3 minus 2 to the power 5. I think that's 32. Yeah, 32 over 80. It's gonna give you 2 over 5. So you just can subtract 2 over 3 minus 2 over 5. You're gonna get 4 over 15. So you're gonna get here with the pi, don't forget the pi, 4 pi over 15. And yeah, that's pretty much. A was 4 pi over 3, and B was 2 pi over 3, and B was 4 pi over 15. So yeah. So for this one, we have something other than y-axis, x-axis. We have y equals to 2. These are our functions with our bound region, and this is our line of revolution. So let's do this quickly. I think the graph is a bit too big. This one's easy. It's an overkill. But anyways, y equals to x. You can fix that a bit. And y equals to 1. Y equals to 2. Something like that, roughly. And this is our bound region. So y equals to x, y equals to 1, and y-axis. So somewhere here. And what else? This is our line of revolution. So what we need is actually for the integral, what's inside the integral is going to be, in actuality, is going to be large radius squared minus small radius squared. This is how you actually do it. And large radius is nothing but the function that's the furthest away from the line of revolution squared minus the, I mean, not the function, you could say the difference in positions. So this minus this, or this minus this, doesn't matter because you're going to square either way. All that squared minus this minus this. Oh no, not this. Yeah, this is the small radius. Yeah, so this minus this, or this minus this, doesn't matter because you're going to square either way. So let me show you what I mean. So v equals pi into integral from, this is our region, not this, not this, not this. So it's from 0 to 1. 0 to 1, and this is what I mean. So large radius is going to be this. So I can do 2 minus x, 2 minus x, or x minus 2. I can do this. It's fine because we're going to square either way. But technically, it's nice to get in the habit to do up minus down for areas, not to get mixed up, for example. You know, if you want. Minus up minus this one, this function, which is 1 squared dx. Let's minimize our graph. Maybe I should have done that before, but I think I can manage, yeah. It looks funny. Anyways, equals pi. We're gonna simplify, so I'm going to keep the integral for now. 0 to 1, this is nothing but 2 minus 1, 1 squared is 1, and this is x squared. Even if you have a minus, it's minus x times minus x to get x squared, minus 4x plus 4 minus 1, so it's going to be 3, because 4 minus 1 is 3, dx equals pi, let's integrate immediately, x to the power 3 over 3 minus 4x squared over 2, so it's going to be 2, 4 and 2 cancel, give you 2, plus 3x, integration of 3 basically, from 0 to 1. Pi, 0 cancels things nicely, so I don't have to do minus 0, whatever it is. So let's do the 1 immediately. So 1 over 3 minus 2 plus 3. What do we get here? These should give you 1, and this with that should give you 4 pi over 3. Let me double check, and yeah, it is 4 pi over 3. So that was number 3. Okay, so for number 4, it actually, once you read it, you might not notice, but you should notice if you graph. There is a trick, I guess, if you don't graph, unless you notice or know it, or it's by experience or something. Y equals, no, y-x, and yeah, so x squared, it's going to be something like this, and y equals to 1. Let's extend it. This is 0, this is 1, and this is 2. This is going to be somewhere here. So we have our first area here and our second area over there. Now, if you try doing the pi integral blah 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 from 0 to 2, you're going to get some weird answer like minus 22 over 5 pi, I think. Like as in pi here, times pi. I think that's just the difference between the volumes or something. So it's wrong anyways, it's wrong, definitely wrong. First of all, getting negative is wrong. That's the first signal. Second signal, it's, if you do the actual math, you're gonna see that there's a difference. That's wrong. So you have to split the areas. This is why graphing in here was useful. I just have to bring it up a bit. I don't have to rescale. Okay. And yeah, so let's get to the equations. So v equals pi integral from 0 to 1, and larger radius, which is here, minus smaller radius, which is here. I only picked these positions because they show the radius clearly. However, the radius is everywhere. The radius is here, 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 because the function is changing at every single point. So anyways, yeah, so larger radius, which is 1 minus 0, which is the x-axis, squared, so 1 squared, which is 1, minus this, which is x squared, squared, which is 4. So x squared squared. dx. The other one, I think you're going to get something similar, except the fact that I think it's reversed, but let's see. So yeah, it's reversed. You're going to have the larger radius, and there the small radius. You can do them in different colors if you want, but you can see them when I'm doing them. So yeah. Yeah. So it's going to be x squared squared, so it's going to be x to the power 4 minus 1 squared squared, 1 squared, which is 1. Same thing with here. It's 1. 1 squared is 1. Just to save time. Dx equals pi, and just immediately integrate. So this here you're going to get x to the power 5 over 5 from 0 to 1 plus pi from x to the power 5 over 5 minus x from 1 to 2, and pi, if 1 minus 1 over 5, that's 4 over 5, so 4 pi over 5. And the second area, or volume, actually, we're getting volumes, 2 to the power 5 blah blah. But actually, let's do it, 2 to the power 5. Yeah, you get 26 pi over 5, and if you add them, 26 plus 4, 30, 30 over 5, 6 pi. Yeah, 6 pi. And yeah, that's it pretty much. Otherwise, you wouldn't have gotten this answer using integrating from 0 to 2, basically. So let's do the number 5, and it's like this. I'm gonna do it up so that I don't have to bring it up again. I can just do it like this. And again, we're doing this if you keep losing term. Cubic root of x, so it looks something like this, and x equals to 1, so it's going to be somewhere here. If we're just define things to be stretchy a bit, I think it looks bad if we stretch things a bit. So this is 1, x equals to 1, and yeah, so the region bound, so we're talking about this region. I just made things bigger. And the x-axis, blah blah blah, is rotated about the y-axis. Again, so we're doing about the y-axis. There's no way you can do with relative to x and the y-axis in the same time. So you have to do relative to y. So we're gonna mess around with the equation. So y to the power of 3 equals x, right? Because it's cubic root. So if you put to the power of 3, then this one's gonna be to the power of 3. And this is x equals to 1, blah blah blah. So from 0 to 1. So you're gonna do volume equals pi, bigger radii, so this is the bigger radii, and this is the small radii. And yeah, pretty much. I'll just pause because this is x equals to 1. No, adi, yeah, you can just put 1, yeah, immediately. This is kind of like your y, you could say, yeah, 1. So from 0 to 1, no, actually we have to work with y's here. So 0 here to 1. If you put 1 here, what do you get? Cubic root of 1, again 1, easy stuff. So 1, so again 0 to 1, large radius is 1, so 1 squared is 1 minus this one, which is the y cubed this time, so y cubed minus 0, y cubed squared, which is y to the power of 6, dx dy, and equals pi. Also, excuse me if I hesitate here and there, it's just that I don't want to make a mistake. And yeah, so y minus y to the power of 7 over 7 from 0 to 1 pi, and yeah, so 1 minus 1 over 7, 0 just cancels nicely, so you have 6 pi over 7, and that's it. So number 6, let's see what this question has for us. Like that. This time I'm doing it beside it because I have space down. Y and x, y equals to x, so something like this, and y equals to 1, and the y-axis, so this region is completely rotated about line x equals to 2. So we're rotating it about this line. This is x equals 2. So the rotation is about this. So this is going to rotate about this line, like that. So we're going to talk about y's, not x's. So we're going to have to mess around again. Here it's y equals to x, so you really don't need to do anything. You already got x. X is y and y is x. So, and you have x equals 2. There's nothing to worry about, so we can just integrate immediately. So what's this one? This one's 0. Here's 1, and 1 is 1. So here 1. Y equals to 1, 1, 1. And yeah, here you have 2. Large radius is this. Small radius is this. Okay. So, and also for y's, it's right minus left. As in, same thing with x's, up minus down. But then again, squared, so, but then again, it's nice to get in the habit for areas. V equals pi, integral from 0 to 1. Yeah, from 0 to 1. We're talking y's. And large radius, so 2 minus 0, because this is 0, squared. Again, I'm being technical and specific so that you are ready for anything and everything they give you. I mean, if you learn it the right way from the beginning, then everything's going to be easy. So again, 2 minus this, which is x, which is y, I mean we're using y's, squared dy, equals pi integral from 0 to 1. 2 squared is nothing but 4. 4 minus, I'm gonna do parentheses because minuses might make me do a mistake, so we're gonna distribute after. Y squared, I like to put the descending order. Y squared minus 4x, 4y. We all got used to x's. So 4 and dy equals pi, and again, step by step, this is nothing but 4. And this is y minus y squared, we're distributing the minus 4y, so minus 4y, so plus 4y, minus 4 minus 4, so 0, cancels nicely, dx, dy, equals, or we can do it below, equals pi, let's integrate immediately, what power of 3 over 3, plus y squared, and over 2 and the 4, so it becomes 2, from 0 to 1, equals pi, and if you substitute you get minus 1 over 3 plus 2, and zeros cancel nicely for 0, and yeah, so 2 minus 1 over 3 you get 5 over 3, again mental math, but I'm gonna double check, yeah, you get 5 over 3, so yeah, that's it for 6. Okay, so for this one I'll be explaining the shell method. I mean the washer is, we've been doing it for a while. It's large radius squared minus small radius squared and pi outside it. But the shell method is important. If you're asked to do it, then you need to know it. Also, it's going to be helpful for university. Yes, it might not be required in school, but it might be required later on. You don't know, you're going to get harder and harder things as you progress. Undergrad, grad school, so on and so forth. So I hope this explanation sticks throughout the year. You remember it, not forget it, and yeah, this is also useful for me because I had to prepare before this. So this explanation is gonna be stuck in my head. So I hope that neither one of us, neither me nor you, forget the explanation, so that we can remember the shell method. So let's get right to it. V equals 2 pi integral from a to b, and then you do r times h, and you derive with respect to something. Could be x, could be y. You just have to figure out what are you doing with respect to. So we're going to leave the formula right as it is. We're going to figure out every single part of it, including filling this empty place here, whether x, either by x or y. How do you start? I prefer starting with h. I've been confused multiple times, and I figured out that I think this is the best way, at least for now. H. You look for your h. Your h is nothing but a line parallel to your axis of rotation. What's your axis of rotation? It's the x-axis. Mark it. Now, what's a line parallel to it? This line, this line, this line, this line, this line, this line. These are all parallel. But I want a line specifically within the area bound. So this line, this line, this line, this line, these are all our h's. Pick one of them as a sample. I pick this one. So this is my h. My r now is nothing but the distance between the two. So let's clean the formula. And this is our r and our h. As you can see, we got them very easily, not confusing at all, and yeah, they always, I mean, at least as I've seen, they always seem to have perpendicular angles. You know, they're perpendicular, perpendicular, perpendicular. So because of this, you can do it in this funny way where you just say axis of rotation, you find your h, and then you just do the I method kind of thing. So now we just did x-axis. For practice, if you want to use the I method, try with y-axis. Sounds confusing, let's do it. So y-axis, pick an h, it's going to be parallel to it. We found an h, found an r, it's our I method. So this is something that can stay with you, and it can be rigid at times, so you can remember it. So it's easier than just being like, okay, what's my h? Is it my height here, my height there? And it gets confusing. No, parallel to the axis of rotation, like this, and r is nothing but the distance between them. So you get your r, you get your h. So now we figured out those. I hope they're 100% clear. Now, with respect to x or with respect to y, how are we integrating? Well, your r, or anything else actually, but let's use our r. Our r can help us figure out whether we're integrating with respect to x or with respect to y. So, is your r a height or a position? Is it increasing like this, or is it increasing or decreasing, of course, like this? I mean, yeah, it's actually doing it as a height. So we are doing it with respect to y. So immediately it's dy. If you don't see that, pick another h. How does it increase? Vertically. Pick another h. Increase vertically. Pick a lower h. Decreased vertically. So they're all vertical, so it's y. So we're deriving with respect to y. So let's go back to the formula. We got this, we got this, we got this. Now our limits. Do not belittle them. These can affect your answer and your whole thing. So we're deriving with respect to y. So what's changing is y's. So we are gonna integrate from a y to a y. So we're gonna do from 0 to square root of 2. This is how you can see it. And if you don't, you can just go again with the h. R is changing. You want to go all the way to the highest h with the biggest r. So it's gonna be square root of 2. Again, we're talking about heights because you're gonna be replacing them in here. These are actually functions of something. In this case, it's going to be a function of y. This is why you substitute y's. This is why these has to be in y form, basically, y's. And yeah, so we can jump right into it. So v equals 2 pi integral, as we said, from 0 to square root of 2. R is nothing but a height. I mean, the distance between the height and this. It is itself a height, and its coordinate is nothing but a y. Pick another r. It's nothing but a y. So as an expression, r is changing, so it's a changing y. So it's a y. H is bigger here. H is the distance between this and this. These are actual lines or curves, you could say, graphs. So the distance between the two is, because you're doing it with respect to y, it's right minus left. This is our orientation. Right minus left. And yeah, so right is what? Is 2. X equals to 2. So 2 minus left. Left is nothing but this. And this is already in form of y. So, or a form of y. So it's just plug in. So 2 minus y squared. Do we square here? No. Do we square here? No. Follow the formula. It's r, h. Oh, we got, this is our h, purely. And this is our r, purely. No messing around, nothing changing. So, and then dy, of course. And now our formula is complete. Now we're just working with math. Let's integrate. So 2 pi from 0 to square root of 2. And here y times 2 minus 2 plus, because minus minus, y squared. This will cancel with this. Dy equals, now this is actually really easy, so let me do it down. 2 pi integrating from 0 to square root of 2. In the next step, we'll actually be integrating because this is really easy. Y to the power 3, as you can see, these cancel and then these multiply. It's lagging a bit. Anyways, y equals to 2 pi, integrate immediately, so y to the power of 4 over 4 from 0 to square root of 2. And just replace 2 pi, 0 cancels nicely, and you're left with square root of 2. This is to the power of 4, which is nothing to the power of 2 times 2. Or you can do it like this, same thing. So this will cancel with the square root and you're just squaring 2 now. So 4. Again, it's lagging. Anyways, so 4 times 2, that's 8. So 8 pi. And let me double check quickly. Oh, sorry, my bad. I forgot the 4. There's a 4 down here. So this is why you get actually 1, and 1 times 2 pi is 2 pi. This is your answer. These methods are just methods. So you're supposed to get here 2 pi. I'm not changing like the entire thing. I'm not, I'm getting, let's say, for example, volume here with respect to y and then volume with respect to x. These could change the values. So you don't have to be worried when the values are different for different, same method, but different axes or different axes of rotation. So if you forgot, it's large radii or radius, because if you're talking about 1, so large radius squared minus small radius squared. If you forgot the orientation, because we've been talking about shell, so things totally changed, new territory. It's follow the, what do you call it, the line of rotation. So it's x-axis, so we're having a change of x, not y. So we're just gonna do 0 to 2. So v equals pi from 0 to 2, and we're gonna have a difference of radii again, as we said. So up minus down. So up is square root of 2. Yeah, square root of 2. Square root of 2 squared minus 0. So yeah, minus, and this one, so it's, oh, you have to change it. So x equals to 2 minus y squared. So x minus 2, or if I just take these like this to make things quicker, it's going to be y squared equals to 2 minus x. So y equals to technically plus or minus 2 minus x. But what are we looking at? It could be the positive. I mean, it looks like this, right? And if you try replacing something, like to get a y, a positive y, yeah, if you, these are positive y's, so it's plus. So immediately it's plus. So this is our y. It's not negative or plus or minus. It's the positive one. So you're gonna have this. Place that 2 minus x squared, because it's gonna be that minus 0. So that dx. Again, familiar territory. We're just back to, you know, simplifying and integrating normally. So this is going to be 2 minus, cancel the square root, so 2 minus x, again don't forget minus distributes, dx. So you can either do that step by step, or you can jump right into it, and but at least get the thing correct, otherwise it's going to give you wrong. So minus minus gives you plus, 2 minus 2 gives you 0, so it's just this. Looks very simple, right? So x squared over 2 from 0 to 2. It's nothing but 2 times 2, which is 2. I mean 2 times 2, which is 4, over 2 gives you 2. Oh, there's a pi, of course. I was like, wait, where did the pi go? And there's a pi. That's gonna give you 2 pi. And of course, we just proved same answer, same thing. It's correct. Okay, so for number 8, and they're asking for diameters, perpendicular planes, extending, I don't know what, circular discs. So we're gonna talk about finding the diameter, finding the area, using the diameter, divide that by 2 to get the radius, pi r. No, first, what's the shape? It's a circular disc, so it's a circle. So we're gonna do pi r squared. If it was a bunch of squares, we're gonna do side squared. If it's a triangle, we're gonna do half base times height. So it depends, like, first of all, where is the edge, and do we even have edges? What shape is it, to find the area, and then integrate the area with respect to x, and you have 0 to pi. So let's start. Diameter, first step, diameter. First of all, we have a, again, circular disc. So what's the function? This is the function. How does it look like on a graph? I'm not gonna do the 3D version. I mean, I can, but I'm not gonna do it just to save time. It's gonna be something like this. This is gonna be 0, you know, like 0, 1. However, this is not pi over 2. But look, the normal, I told this, I think, to someone before, but when you divide by 2, think of it that the x's need to be larger and larger to make a difference. So when you divide by 2, you're kind of like slowing the graph down. So a normal cosine might have been like this, and you might have already gotten here, and you might have already are going to transition. But a pi over a cosine x over 2 is going to be slower, so it's going to change more over time. So rather than having a pi over 2 here, I mean, usually where it would go and like hit, it will become like this. Its new point is going to be pi 2 times. And actually, if you double check, if you put pi over 2, you actually get cos. I mean, if you put pi, you're going to get pi over 2. So cosine pi over 2, that's 0. So you made sure that actually works. So yeah, we're having this area, but this is not the area we're integrating. We're having discs. This is why I wanted to do the 3D, but anyways, it's actually discs all around this with diameter. What the hell happened? With diameters like this. This is the diameter of the circle, and the circle is like 3D, up and down, up and down the graph. This is like the z-axis, if you could imagine, up and down, up and down. So yeah, anyways, so the diameter is nothing but this minus that, which is the function itself. So we can just jump in and write, say, cosine x over 2, and radius is nothing but over 2 of that. So cosine x over 2 over 2. It's not cosine x over 4. No, it's over the entire thing. That's the radius. So area is pi r, which is cosine x over 2 squared. That's r squared, and then integrate. So volume of the solid is pi, not pi. Again, it's not the washer or something. We got the area, so just integrate the area. Integration of the area. Now I'm gonna take the pi. So from 0 to pi, and this is the thing, just square. So cosine squared x over 2 over 2. I can take the over 2 out. So pi over 2 dx. In this case, one good thing that you can do is you go back to the double angle formula. So pi over 2, because we're not going to integrate cosine squared, we're going to refer back to the double angle formula. So yeah, so with this one you're going to do half plus half cosine 2 times the angle. So it's going to be cosine x, because 2 times x over 2 is x, dx equals, I just replaced. Now we integrate pi over 2, and this is 1 over 2, this is 1 over 2 x plus half cosine. Integrating cosine will give you back sine, because if you derive sine you get cosine, integrate cosine you get sine. So half sine x, and 0 pi over 2 outside. Here you get half pi plus half sine of pi. Pi is nothing like 180 or something, so sine of that in the unit circle is going to give you somewhere here. So this is 0, just like sine of 0, 0, sine of pi is 0. So this is going to be 0, so it's going to cancel, and zeros here, all of them cancel. So this cancelled, you're left with half, and you get pi squared over, wait, I think I did a slight mistake. Oh, if you square this, you get 4 down. If you square this, you get a 4 down. So actually it's 4 outside, 4 outside, 4 outside, 4 outside. So this is 4 times 2, this is 8. And that's the right answer. So my bad, it's just that I forgot that this is squared, so I did not square this. So when I took it out, I just took it out as 2, not 4.
Let's move on to the grid. And grid questions number 29 and 30 are relevant to this section, and I'll give you guys a few seconds and we'll solve them together. Okay, let's solve it together. A function is defined implicitly by the equation 2x cubed plus 2x plus y squared minus 3y equals 2. In the xy plane, the slope of the tangent to the graph of the function at the point 1, 1 is equal to k, where k is a constant. Find k basically. So all you have to do is find the slope. So find the derivative and substitute 1, 1. So that's very simple. 6x squared plus 2 plus 2y y prime minus 3y prime is equal to 0. Take the y prime out. 2y minus 3 is equal to minus 6x squared minus 2. So y prime is equal to minus 6x squared minus 2 over 2y plus 3. Sorry, 2y minus 3. Now they want at 1, 1. So we do it at 1, 1. And we get minus 8 over 2 minus 3 is minus 1. Cancels. The answer is 8. That's the slope, and that's what they wanted. So 29 is very simple. 30 is a little more challenging, so we'll do 30 now. 30, we are given that y squared minus x squared is minus 64. We need y prime at y minus 2. Okay, so y squared minus x squared is minus 64. We need y prime, so y prime equals question mark when y is equal to minus 2. So first we need to find y prime. So it's y prime is equal to, let's see, 2y y prime minus 2x. Let's not call it y prime to make it simple, f prime of x, if it'll look better, is equal to 0, right? So y prime is equal to 2x over 2y. So here's the y prime. Now to find y double prime, we do quotient rule. So it's 4y minus 4x y prime, yeah, over 4y squared. You square the bottom, it's 4y minus 4x, you substitute, you get 2x minus 2y, all of that over 4y squared. I'm gonna continue here, 4y minus 8x squared over 2y, over to give 4y squared. You have to do common denominator, it's 8y squared over 2y minus 8x squared over 2y over 4y squared, right? Yeah, 4y squared. You take the 2y to y down, it's 8y squared minus 8x squared over, let's see, 8y cubed. Cancels. We know that y squared minus x squared is minus 64 over y cubed, which is minus 2 cubed. So it's minus 64 over minus 8 is equal to 8. And that's our answer. So these are two questions related. 32 is a direct application. 31 is coming in the exam. It's covered last year. So let's do them both. I'll give you guys a few seconds. You guys can solve 31 and 32 and then we'll check together. Let's do 31 now. The volume of a sphere is increasing at the constant rate of 5 centimeter cube per second. When the radius is 5 centimeters, it increases at a rate of 1 over k pi centimeter per second, where k is a constant. Find k and enter its value as a whole number. So in this question, basically it's dv over dr, or sorry, dv over dt is equal to dv over dr times dr over dt. It's equivalent because this cancels. Let me just fix this. dv over dr times dr over dt, right? We have dv over dt. We have the rate of change of the volume. It's constant, dv over dr. We're looking for this. So this is in effect dr over dt is equal to dv over dt by dv over dr divided by the rate of change of the volume is 5, and this is the derivative of the volume, which is 4 pi r squared when r is equal to 5. Moving on here, or let me just continue here. We get 5 over 4 pi 5 squared, this cancels, 1 over 20 pi. So k is 20. I'll give you guys a few seconds to check and then we'll do 32. Okay, let's check 32 now. Consider the function f given by y equals f of x equals x cubed minus 3x squared plus 2x, and let L of x be the linearization of f at x equals 0. What is the value of L of 10? Okay, let's check f prime of x. You immediately find the derivative. It's 3x squared minus 6x plus 2. And this is at x equals 0, so this is all gone, it's 2. Just fix that, yeah. Now we got y minus 0, because it was 0 in the beginning, into 2 into x minus 0. So it gets y equals 2x, which leads to L of x equals 2x. They're asking us for L of 10, so that's 2 times 10, giving us 20. And this is the answer. Grid application. Let's do grid question number 33. I'll give you guys a few seconds to solve. Okay, let's solve it. Consider the function f given by y equals f of x equals this. Let x0 equals 1 be an initial estimate for the root of f of x equals 0. The next estimate for a root of f of x equals 0 using Newton's method, this is important, is x1 equals minus k over 3, where k is a whole number to be determined. Give the value of k. Newton's method is something we did not cover. I feel like they meant for it to be self-studied, but since it is part of the grid question material, let's just have a quick go over it. And since they only want the next estimate, it's a very short and easy question to do. So let's solve. So what Newton's method wants us to do is, basically it's xn plus 1. So the next estimate is x0 minus f of x0 over f prime of x0. That is the formula. We have x0, we can get f of x0. We don't have f prime. So let's just quickly find f prime of x, which is 6x squared minus 3. 6x squared minus 3, right? Now let's see. x0 equals 1 is the initial estimate. So x of n plus 1, or let's call this x1, equals 1 minus f of 1 is, let's see, 2 minus 3 is minus 1, 5 over. Now 6 squared, sorry about that, 6 times 1 minus 3 is 3. So basically it is 1 minus 5 over 3. Substituting, you get 3 over 3 minus 5 over 3 minus 2 over 3. So k is 2. And that's how you solve grid question number 33.
So this question is really easy. You just need to split the integral and then take the constants outside to make things easier. So 36 over pi cubed times the integral of x squared dx minus 15 integral of sine 3x dx. So 36 over pi cubed, the integral of x squared is x cubed over 3. This and this cancels, you get 12 minus 15 integral of sine 3x. You can use this if you keep forgetting, let's say, the integral of sine, cosine. Through practice you will be able to remember, or if you can try memorizing them. But then again, if you feel like this will assist you, then sure. The easy way to remember this itself is sine, cosine, minus cosine, you go back to sine. So, and you can, if you want, you can shape it yourself, as in, what's the derivative of sine? You should know it's cosine. What's the integral of cosine? You should know it's sine. So derivative of cosine minus sine, and so on. It will be a cycle. You'll just know what to fill. So, of course, this doesn't account for the fact that when you do integration, you have 1 over k if you have kx over here, for example. So in this case, it will be minus 15 into sine, integral of that will have minus cosine. So minus, and here 1 over k, so 3 cosine 3x. And in this case, you have plus c because both of them are indefinite, indefinite integrals. So we said here 12 and then 3 with this 5, minus with minus cancels. Well, technically, you get a plus. So 12 x cubed over pi cubed plus 5 cosine 3x plus c. And they just want the I of pi, where they say this is I, so this is our I function. This is I of x. So what's I of pi? I of pi is, put here pi, the pi cubed cancels with the pi cubed, you have 12 plus 5 cosine 3 pi. One easy way to do this is just immediately, well, actually, if you want to do it with a calculator, you can, but you can just go with cosine of 3 pi can be written as pi plus 2 pi. Cosine's period is 2 pi, so this will make no effect. Basically, what will happen as a graphical intuition is that whatever angle you had, which actually is pi, so let's say like this angle will be going like that and back here. So you did nothing, basically. You did nothing at all when you add 2 pi. So because we're back to the same place, you can just cancel. So cosine of pi, it's 180, and we want the x, this is cosine, this is minus 1. Why am I telling you this rather than calculator? This will actually honestly help you sometimes, especially with intuition and all that. So yeah, so 12 plus 5 into minus 1, so you basically get minus 5. 12 minus 5, you get 7, and that's pretty much it. For number 35, again you split the integrals, so you get integral of 109 2x squared dx plus the integral of 8 dx plus the integral of 3 pi secant squared pi x dx. So now you just integrate normally, so 192x squared, integral of that is x cubic, 192 over 3, that you get 64, plus 8x, plus, this is 8x by the way, so plus this one, this, because if you do, let's say, the integral of a derivative of a function dy, then you get the function itself, because this is an antiderivative and this is a derivative, so they cancel each other and they give you the function. So basically, if you derive this and then if you integrate it, you get y, because you're deriving, then you're not deriving anymore, you're removing it, integrating it, so you get the function itself. So with that, is secant squared pi x a derivative, or even the entire expression, doesn't have to be this only, is this a derivative of a function that we already know? Yes, it's tan, yeah, tan. So in this case, you'll get tan of, don't put this, because if you put this, then you're saying integral of tan. You cannot simplify this and then somehow have the tan on its own. Of course, you have stuff here, stuff there. So if you write tan, don't write the integral, because tan is gotten from the integration of the derivative of tan, which is secant squared. So tan pi x, but we're not done. We have pi x. So if you integrate a derivative, you're gonna divide by the derivative of what's inside. So 1 over pi times 3 pi. Pi and pi cancel, and you're left with 64x squared, no, a cubed, plus 8x plus 3 tan 3 pi x, and then just substitute 1 over 4, so you get for this one 1 over 4 cubic, you get 4 fourths, so 16, I think, so 64 over 4 cubic, you get 1 actually, yeah, 1, plus 1 over 4, you get here 2, plus 3 tan of pi over 4, pi over 4 is 45, sine of 45 over cosine of 45 gives you 1, because they're the same, radical 2 over 2. So here you have 1 plus 2, you get 3, plus 3 into, here you get 1, so 3 plus, so you get 6. Final answer. So for this one, again, you need to break the integral, so 12 integral of cosine x dx plus minus actually minus 6 into the integral of sine x dx, and then this is equal to integral of cosine, you get sine, so into sine, actually no need for parentheses, sine x minus 6 into the integral of sine x is minus cosine, so here like that, so 12 sine x plus, because minus 6 cosine x, and you have plus c because it's an indefinite integral. This part is ix, as they said over here, ix plus c, and we just want to substitute theta. If you substitute theta, they told you if you do the theta, you get cosine theta being this, sine theta being that. So it's 12 into sine is, we have 3 over 5, plus 6 into the cosine, which is 4 over 5. This is fairly easy. If you do the addition, I believe you get 12. 12 times 3 over 5, 36 over 5, plus 6 times 4 over 3. I mean over 5. Whoops, my bad. Let me just fix this. Minus 6 times 4 over 3. Okay, so you do get, yeah, okay, you get 12. It's pretty much. I just had to double check. So just split the integral for this, you get integral of 2x over x to the power 4 dx plus the integral of 7, I mean not plus, this is minus, integral of 7x squared over x to the power 4 dx equals, this cancels with this, so you have 3, this cancels with this, you have 2, and if you want I'll write it like this, minus 7 into the integral of, this is minus 3, x minus 2 equals 2 into the integral of this, you divide by minus 2 into 1 over x squared, minus 7 into, you know, add 1, you get minus 1, divide by that, you get over minus 1, so actually the minus and minus cancels, you get 7 here, and plus 1 you get minus 1, so 1 over x. Let's continue here, this and this cancels, so you get minus 1 over x squared plus 7 over x. And of course this is an indefinite integral, so you add plus c and dx here, don't forget if this is written, well it is written, but yeah. So I of 1 over 3, this is I, this is taken to be I, so I of 1 over 3 so I of 1 over 3 is 1 over 3 squared 1 over 9, and then there's 1, so it becomes 9, so minus 9, plus 7 over 1 over 3, so 7 times 3, here you get minus 9 plus 21, you get 12. 12, yeah, pretty much. So I distribute the secant x and split the integral, you get integral of 8 square root of 2 secant squared x, secant x tan x dx, don't forget the dx, minus the integral of 7 secant squared x dx. And this is an actual derivative of a function which is secant of x. So the integral of a derivative gives you the function. So this is the derivative of that. The integral of this gives you this. So 8 square root of 2 times secant of x minus this is the derivative of tan of x. So the integral of a derivative gives you the function, so minus 7 tan of x, and this is nothing special, plus c, indefinite, so plus c. This itself is I of x, so this is equal to, or I of, actually, I of pi over 4 is equal to, replace pi over 4, so 8 square root of 2, secant is nothing but 1 over cosine, so of cosine pi over 4, minus 7 of, or times tan of pi over 4. And with this you get, so first of all, 8 square root of 2, cosine of pi over 4 gives you 1 over radical 2, or radical 2 over 2, same thing. If you rationalize, you get radical 2 over 2. So 1 over radical 2, so 1 over radical 2 gives you radical 2, so times radical 2, minus, you can do this with the calculator, but I prefer doing it mentally. Radical 2 gives you 2, so 8 times 2 you get 16, 16 minus 7 you get 9, so your answer is 9. So for this one you need to go back to using u equals, we pick the one that is useful. So if we pick x squared, it gives us a derivative of 2x. 2x does not help us with this, useless, so we're gonna try picking this instead. So if we do the derivative of this, you get 3x squared, and it is helpful because these two cancel, because you know you divide by the derivative. So this is a much more useful choice rather than that, very useless over here. So you pick x cubic plus 9, so du over dx, you get 3 x squared. Rearrange dx, dx, and here du, so du over 3x squared. And let's go back to the equation itself. So this becomes the integral of x squared over 3x squared times radical of u, because we said this is u, times du, because you know this is put instead of this. All I did is take the denominator and put it there just to cancel those two immediately. You're left with the du. So this is what you get now. So let's keep on going. And these cancel, so you get 1 over 3 integral of u to the half du. So 1 over 3 integral of this, add 1, you get 3 over 2. Divide by that, so you get 2 over 3 times 2 over 3 u square root of u, because u to the power of 3 over 2 is nothing but u and u half, and this is u half is nothing but square root, so pretty much those two multiply, so you get 2 over 9 u square root of u, and let's replace back u by its original value, which is 2 over 9 into x, this is u, x to the power of 3 plus 9 into square root of x to the power of 3 plus 9. Now this is nothing, you can do it in the calculator. Actually let's do it, it's faster. So it's 2 over 9, by the way this is plus c, this is plus c, yeah, plus c, plus c, and this itself is I of x, and I of 3 is so let's put that in the calculator. You get 2 over 9 times 3 to the power of 3 minus, or plus, actually plus 9 times square root of 3 to the power of 3 minus 9, no, plus 9, yeah, you get 48, which is the correct answer. So pretty much. So for this one, it's like the previous question in that you need to pick your u. Your u is the most useful function. If you pick secant, you are not gonna find anything useful. Secant squared, again, you're not gonna find anything useful. Tan squared, there's an easy way, and that's tan. So you end up picking tan. So your function would be tan of x. Now du over dx gives you secant squared of x, which is why it's useful, because those two divide when you do this, of course. Dx is du over secant squared x, and this is where they divide. 21 integral of tan, we said tan is tan x is u, so u squared, times secant squared x over secant squared x, I got from here, times dx, no, times du. These cancel, so we're back to square one. 21 u squared du. Now with the integral of this, you get u cubed over 3. This cancels, gives you 7 plus c. 7 into, let's replace u by tan, so tan cubic of x, and we're done. Part c, plus c, I mean, and this is pretty much I of x. So I of, they're asking pi over 4, so pi over 4 equals, put pi over 4, you get 7. Tan of pi over 4 is 1, 1 cubic is 1, so you get 7 here, and you're done. So for this one, there's nothing special, but if you want, you can use the u again. Of course, you will not be picking a function here other than this, because there isn't a function. This can be considered a function, but its derivative is 0, and it's nothing you really want to work with, so just pick the obvious one. So x plus 25, du gives you 1, d over dx, and dx gives you, of course, du, because 1, so no need to even work with it. So you get this function becomes the integral of 2 over, this is u, so cubic root of u du. So basically you can integrate immediately. If you want, I'll take the 2 outside. So 2 into integral of this. This is the same as u to the power of minus because it's down, and 1 over 3 because it's cubic root. So if you add 1, you get 2 over 3, and that's your new u. I mean, after integrating, of course. So divide by 2 over 3. So you get times 3 over 2. And here you get u 2 over 3. So this cancels. You get 3 into u is originally what? X plus 25. 2 over 3 is nothing but squaring and then cubic root of. Square can be outside or inside, doesn't matter. So yeah, so the 2 up is for squaring cubic root. If you have to the power 3, it's to the power 3, to the power 4, and then over is the square root or the cubic root or the so on and so forth, basically. So yeah, and they just want to substitute the value. So 3 times, let's put this in the calculator. So 100 plus 25 is 125. Square of this, you get a huge number. Cubic root of this, you get 25. So 3 times this, you get 75. And by the way, this is plus c, and we want, again, this is plus c, and when we substitute, we actually substituted this as I of x, and this is nothing but I of 100, just to be formal. And yeah, pretty much. For this, pick the best choice of u again. Cosine x gives you sine x, but sine x does not cancel with sine cubic, or like as in cubic of sine. So sine to the power 3 of x, it doesn't cancel. You're left with sine squared x if you cancel, or try to cancel. So picking the higher power is better here, because sine other way, because sine and cosine are like, they're not inverses, but yani their derivatives will give you the other, yani. So pretty much. So u equals sine of x, and du over dx gives you derivative of sine of x is cosine of x, and dx equals du over cosine of x. And if you go back to the equation, you have integral of 32 cosine x over cosine x times sine. We said sine of x is u, so u cubic times du. This and this cancels, so you are left with 3 on 20. Integral of u cubic is u to the power 4 over 4 plus c. 4 and 3 to 0 cancel. You get 80. Yeah, 80. 80 into u is what? Cosine, right? So cosine, no, sorry, sine. So sine squared to power 4. So sine 4x, yeah. Plus c. This is I of x. So I of pi over 6 gives you 80 into sine of pi over 6. Let me just fix this. So sine of pi over 6, all of this to the power 4. I wrote it differently just to make things clearer, just to know that what is sine 4 over this. So it's this, sine of this to the power 4. And yeah, pretty much. So sine of pi over 6, if you know it mentally, it's half. So it's the 2 to the power 4, it's 2 times 2, 4, 4 times 16, so 16 over, but we can double check. So sine of pi over 2, pi over 6, you get half. This to the power of 4, you get again 1 over 16, just like how I said it. Times 80, you get 5, and that's your final answer.
Okay, question 43. For f of x equals x squared minus 2, find c for average value, and then find c squared because most likely it will be in a radical form. So average value, you find it by dividing the area under graph by the width. So you're finding the average height, if you can get the intuition of that. So the formula is integral of x squared minus 2 dx over, from 0 to 2, obviously, 2 minus 0. Now, over 2 of x cubed over 3 minus 2x dx, not dx, sorry, it's this form where it's from 2 to 0. So then the final answer will be, for average, f average, x cubed you sub it in, so 2 cubed, 8 over 3, 8 over 3 minus 4, so 4 is 8 over 3 minus 4, 4 is 12 over 3, so 8 minus 12 is minus 4, so it's minus 4 over 3, and then divided by 2, it's minus 2 over 3. That's the average value. So minus 2 over 3 is equal to x squared minus 2. Or actually, let's make things simple. You substitute in c, so it ends up being c squared minus 2. And then move 2 to the other side, so c squared becomes 2 minus 2 over 3, which is equal to 6 over 3 minus 2 over 3, so we end up getting 4 over 3. So if you notice, we already got this form. C squared equals something over 3. So k over 3 equals 4 over 3, so k is 4. C squared equals 4 over 3 equals to k over 3. So the answer is 4. And that's it for 43.
So in question 44, they ask us to find the integral going from 3 to 0 of 3x squared radical x cubed plus 9 dx. So for this question, we have to use the substitution method. So we say that u is equal to x cubed plus 9. So then we derive it, and it becomes du over dx is equal to 3x squared. Then what we have to do in the substitution method is make dx the subject of the equation. So dx is equal to du over 3x squared. So then the integral becomes 3x squared radical x cubed plus 9, which is equal to radical u. And then we substitute du over 3x squared in the place of dx. So then the 3x squared and the 3x squared cancel out, so the integral becomes radical u. And then if we integrate that, it becomes x cubed plus 9 to the power of half plus 1 over half plus 1, which is equal to 3 over 2. In a simplified version, this becomes 2 over 3 times x cubed plus 9 to the power of 3 over 2, going from 3 to 0. Then when we simplify it, it becomes 144 minus 18, which is equal to 126. Question 45 asks us to find the integral from pi over 10 to 0 of sine 5x cosine squared 5x dx. This question we also have to use the substitution method. So we say that u is equal to cosine 5x. So the derivative, or du over dx, is equal to minus 5 sine 5x. We make dx the subject of the equation, so dx is equal to du over minus 5 sine 5x. So the integral from pi over 10 to 0 becomes sine 5x cosine squared 5x times du over minus 5 sine x. And then we can cancel sine 5x with sine 5x, and it becomes minus 1 over 5 integral u squared du. And then we can integrate u, so it becomes minus 1 over 5 times cosine cubed 5x over 3, going from pi over 10 to 0. If we simplify, we get 0 minus 1 over 15, which is equal to 1 over 15. So then in this question, k is equal to 15. Question 46 asks us to find the integral from x cubed to x of pi theta cosine pi theta d theta. But as we took, the integral can't go from a variable to another variable. It has to go from a constant to another variable. But we can use the principles we took to do that. So we can write the integral going from any constant, I chose 0, to x, 5 theta cosine pi theta d theta, plus going from x cubed to that same constant of 5 theta cosine pi theta d theta. We can switch the first integral so that it goes from x to 0, but in order to do that we have to add the negative sign before it. Now the question wants us to find f prime of minus 1, so then it becomes minus 5x cosine pi x plus 5x cubed plus 3x squared times cosine pi x cubed. Now if we substitute minus 1 into that equation, we get minus 5 plus 15, which is equal to 10. Question 47 asks us to find the integral from 5x to x of 15 cosine squared w dw. Again, we have to split the integral so that they go to a constant. So they go from 0 to x, 15 cosine squared w dw, plus 5x goes to 0, integral of 15 cosine squared w dw. And we flip the first integral so it becomes minus from x to 0, 15 cosine squared w dw. They want us to find f prime of 1, so it becomes minus 15 cosine squared x plus 15 times 5 cosine squared of 5x. And if we substitute 1 into that, we get minus 15 plus 75, which is equal to 60.
So for number 48, all we care about is volume. It's, to give a solid, this is the equation and these are the points, and it's about the x-axis. Okay, so it's going to be v equals pi into the integral. What are our points? It's from 2 to 3, and it's going to be about the x-axis, so minus 0 squared, because that's the radii, the second one. For the first one, it's going to be 1 over square root of x cubic squared, minus, as I said, 0 squared, so it's going to be 0, so cancel. And then dx equals pi, we're going to do it step by step, so 2 to 3, and this is going to be 1 over x cubic, because the square and the square root just cancel, use up. And we're going to integrate right now. So pi into, if you integrate this, if you want to do it step by step, take this up, it's going to be x to the power of minus 3, and then minus 3 becomes minus 2, and then divide by that minus 2. It's going to be, you guys by now know that, so that's why I'm going quickly over it. So 2 to 3. Let me double check. 2 to 3. Yeah, 2 to 3. Okay. I'm going to take, for simplicity, because sometimes people can do mistakes here. I myself do end up doing mistakes sometimes for larger actually ones where you have plus, minus, and so on. Yeah, so I just take the constants out so that I can do things easier. Here you can take the common factor. It's just one term, so yeah. 1 over x squared from 2 to 3. So it's basically pi over minus 2 into 1 over 9 minus 1 over 4. If you crunch that in your calculator, you're going to get 5 pi over 72. This is a 9, this is a 4. And this is your final answer. Again, a similar problem. We're given a y and we're given x, and it's rotated about the full rotation about the x-axis. Bounded. So again, so if you want to take an idea on how the graph looks like, because it will help you define what's happening here, like what do you do. So x equals to 8 is nothing but a vertical line. Is there anything about it's rotating about the x-axis? Okay, this is how the rotation is going, and this is gonna be the line. It's something like this. I just roughly drew it. It looks weird, but yeah. Yeah. And about the x-axis, volume. Okay. So they're talking about this above the x-axis. This is above the x-axis. So we're talking about this region right here. So bounded here, from here to here. So we're going to integrate from this region, that area, and then around the x-axis. So it's going to be v equals pi, the integration from 0 to 8. And it's going to be up minus down. Down is just 0. so that's why 0 squared, I mean, because you know square the radii, so radii 1, which is this, squared minus radii the other, which is squared, so you can get 0 there. So just the one up first. Yeah, so 5 over 4 cubic root of x, all of it squared, dx. I'm gonna take the constants out, so pi times 5 times 5, 25, over 4 times 4, that's 16. And we're gonna left inside the integral from 0 to 8 of, I mean, it's up to you. You can do x squared inside all of it in the cubic root, or you want to take squared outside. It's the same. It's the same. And then equals. Here it might be easier to just use exponents as fractions, because this will make it easier for you to add 1 to see what it means to actually integrate normally. Yeah. So this is going to be, add 1, you're going to be 5 over 3 x, and this is going to be 3 over 5 because you divide by that exponent. Yeah, by the, yeah, divide, so you multiply by the reciprocal. So 0 to 8, 0 is going to give you 0, so immediately put 8. 8 under the cubic root, I mean, this is just mathematically because I'm getting my calculator right now, but you will end up with, over here, you put 3 over 5 times the cubic root, so you're going to get 2 to the power of 5, that's 32, so 96 over 5 times 25 over 16. You're going to get 30 pi. And that's the final answer. Okay, so for number 50, graphing is a good option. So let's do a small sketch. So this is y, this is x, and this is nothing but a line. Don't be intimidated by the square root. It's just square root of 2, constant. I mean, if I fix this slightly, anyways, this is going to be the line. I'm not going to bother writing anything because it's just to save time. Here, can x be negative? It never can, because there's a square root here. So this entire area is ignored. It will never be graphed for this graph. And can y be negative? No, because these will always give you positive answers. Try negative. You cannot, because there's a square root. So try positive. Well, I mean, with a positive you'll always get a positive, but aslan you have a square and you have a square root. Yani these will never allow negatives in the first place. Like this one allows, but will never give. This one doesn't allow in the first place, so how will it give? So yeah, so this whole region is not there, because again, as we said, the negative y is not there, the negative x is not there, so you're only left with this region. And this can be written as 5 over 2, because you know, if you try measuring it, and it will be 2.5 in other words, as you can see. This means that x will always be increasing. So draw it like a parabola, like this. And so we got our graph. I mean, it's not really bending, but yani, excuse my poor drawing skills, but anyways, this is from 0 to, we have to find this point. So it's x squared times the square root of x equals square root of 2 times x. Cancel x with the 2, knowing that, you know, like I'm cancelling in x basically, knowing that x is 0. If you cancel without doing this, you did something wrong. So yeah, so I'm gonna square it also. Square, not square, it's square and square. So you're gonna get x to the power of 3 equals 2, and then you do the cubic root of 2, and that's your other bound cubic root. Anyways, so let's delete some of those to have space. Now that we know the bounds, we can integrate. So v equals pi. I mean, technically you could have done that blindly, as long as you know that you're doing it with the x-axis, because the only thing you're going to do is difference of squares pretty much. So I don't think it's going to matter which is minus with which. If you get a negative, technically all you need to do is negate just to get a positive. But anyways, yani, I don't think it matters much if it's a multiple or something. Anyways, so 0 to square cubic root of 2, and here is the upper one, so it's going to be the line. So this squared minus the other one, x squared square root of, why am I not minusing, let's say, something here or there? Because we're minusing from the line of rotation, which is 0 aslan. So you're back to the line itself, where the original y is, the line or the graph or the curve or whatever it is. And yeah, square dx, and just integrate normally. So pi, and this one's going to be from 0 to cubic root of 2. It's going to be 2x squared minus x to the power of 5. And this one's really easy to integrate, right? So it's pi in 2. So x to the power of 3, 2 here over 3, minus x to the power of 6 over 6 from 0 to cubic root of 2. If you do this, you're going to get 2 pi over 3. And yeah. For this one, you can draw, you can do whatever you want. Like, you can even do the fancy stuff where you do the kind of like imitate 3D, like that. It's gonna be the z-axis, and like this is the one curve. This is the like that, and this is the circles. Anyways, but I'm just gonna hop right into the math or the calculations. So just find the diameter. Basically, diameter is one minus the other, the upper one minus the lower one. The upper one is going to be the one with the negative slope. It's going to be above it, 4 units above it. This one's 4 units below the what do you call it, the x-axis. So it's actually a difference of 8 units. Anyways, I mean, it depends. If you're here 8 units, if it's here it's different, so on. So this is why we actually have to find the diameter in terms of these x squared and so on. So the diameter is d equals the upper one, we said that one, so 4 minus x squared minus x squared. Again, write parentheses because you're gonna have to distribute the minus. So it's gonna be 4 minus, step by step, minus x squared plus 4. So the 4's add and the x's add, so you're gonna get, if you write it like this, you're gonna get 8 minus x, 2x squared. Now, we don't need the diameter, we need the radius if we want to get the volume. So v equals pi from, we're given 2 minus 2 to 2, so minus 2 to 2. Radius, so we're gonna divide by 2. So it's this over 2. If you want, I'm gonna write it step by step. Now you might say, why didn't we just take one of them? This happens to be symmetric. They happen to be the same function about the x-axis. These are 2 points about the x-axis and they're the same function. These 2 points made it that the diameter is the same as just like picking one of, I mean the radius is nothing but picking one of these basically, or picking the positive one if you want, or something. Anyways, but this is just because it's symmetric. Otherwise you have to do it normally like this and just divide. Square this dx, so if you divide you're gonna get pi integral from minus 2 to 2 of 4 minus x squared dx. If you square, you're gonna get integral from minus 2. I'm gonna jump right into the integration after this. X to the power 4 minus 8x plus 16 dx. This is 16. And then, you know, immediately finally we integrate x to the power 5 over 5 minus 4x squared that divided by 2 plus 16x, and then just substitute the numbers. You're gonna get somewhere around, and actually not around, it's an accurate number, 512 pi over 15. And they're asking for what? What's the number times the pi over the 15? It's 512, so it's the answer. For number 54, it's really easy. It's just basically using the Lin concept, which is literally what's written here, like the derivative over the function. When you integrate that, you pretty much get Lin of the function. So the only trick, I guess, to just do this immediately is, let me rewrite it. But one thing I will do, which I have left out right now, is the 6. What's the derivative of this? It's 3x squared. So I want here to have 3. And I have 6, so what's left is 2. I'll keep it outside. What I have done is basically have the derivative of this function. Well, I mean, derivative of this is 0. This is why I disregarded it. But actually, if you have something, you have to take it into account. Otherwise, you're going to get something else. So you can just hop right into it and do 2 ln of the function x to the power of 3 plus 2. Because its derivative is above it, and it's divided by the function, which is pretty much what's written here. Yeah. So from 0 to 2, so it's nothing but 2. It's basically ln minus ln, so I can divide the lns. I mean, not the lns, what's inside the lns, I can divide them. So put 2 here, you're gonna get 2 cubed, that's 8, plus 2, that's 10. Put 0 here, you're gonna get 0 cubed plus 2, that's 2. Don't forget the 2. You're not gonna get 0 down. Divide them, you're gonna get 5. 2 ln 5 is nothing but put the like this as an exponent. So it's gonna be ln 25. And that's it pretty much. So this one's really easy, just do let u, the simplest of the simplest. So let u equals, in our level is just gonna be the pretty much the exponent, the hard what do you call term, or the hard expression, stuff like those. So minus cotan y, but in real life we're getting the one that actually cancels the derivative. So sometimes you have to try and try and try. Yeah. So just you're gonna do du equal du over dy, because we're working with y, equals, derive this, you're gonna get cosecant squared y. How did I know? Derivative of cotan is minus cosecant. With a minus it becomes plus. Now cosecant is nothing but 1 over sine squared of y. So when you take dy to the other side and take this to the other side, so if we're working with this, take this to the other side and this to the other side, you're gonna have them multiply. So you're gonna have dy equals sine squared y times du. And then we're back to the original integration where you have e to the u, 6e I think, yeah, 6e to the u, because we replaced the minus cotan, over sine squared y times sine squared y, this is why they cancel, du. With this and du, it's just really easy, it's just 6e u plus c, because it's indefinite, there are no constants, there are no limits or boundaries, and then just replace back, so minus cotan y plus c. They told us that this is some function they defined to be e of x, and they're asking us what's e of pi over 2. So just place pi over 2. So 6e to the power of minus cotan pi over 2. It's nothing but 90. Cotan is nothing but cosine over sine. The cosine of 90, I don't care about sine. Sine, it will give you 1. But cosine of 90 is going to give you 0. So the entire expression is 0. So this entire exponent is 0. So 6e to the power of 0 is nothing but 6 times 1, which is 6. This is why the answer here is 6. For this one, it's really easy. Again, I have one small trick. It's the same trick as this one, the 54 one. So just pick the integral again. It's ln 10 here, and I'm gonna write again. I'm gonna omit something for a reason. So if you derive this, you actually get this. So, and what I have left is 3, so keep the 3 out. This dx, of course. And so it's 3 times ln of the function, not its derivative, the function. So ln of e to the x plus 2. I mean, in this case, I really don't need, by the way, you need absolute value. But for me, I'm not putting for this one, and I think it was wrong for me not to put for that one. But so always remember to put absolute value. This one's always positive, so I'm not gonna put the absolute value, knowing that it's positive. I know that it's positive, but if you want to show and then just remove it later on, or when you phrase it if it's written or something. But anyways, so yeah, 3 times. With this, it's going to be ln, and I said that if you have differences, that like ln of this put that, and then minus the ln of this put that, it's going to be ln and then divide by what you're going to get here. So put ln e to the ln 10, it's going to give you 10 plus 2, which is going to give you 12, over e to the 0, which is going to give you 1. Don't forget, it's not going to give you 0, it's going to give you 1. Because for those of you who put this and somehow got 0 and then wrote 2, so 2 plus 0 is 2, and you're going to do this and you're going to get 6 ln 6, and 3 ln 6, and you're just going to get one whole number. You're going to put 3 here and you're going to get 6 to the power of 3, which I mean, I calculated right here, but it's insignificant because it's wrong. You're going to get 216. It's the wrong answer. So it's not 2 because it's e to the 0, which is not 0, it's 1. Any number to the power of 0 is 1. So 1 plus 2, that's 3. 3 cancels with this. I know this is, by the way, a mental mistake. I sometimes do it. Sometimes. So this is 4. So ln 4 to the power of 3, which is 4 times 4 times 4, which is 64. Double check. Yeah, it's 64. So yeah. And we're done with this one. This one's really easy. I mean, I can jump right into the integration. Let's do it. Let's jump right into the integration. 3 times e to the x dx. It's going to be the same. 3x d to the x from ln 4 ln 8. This is really beautiful because you just simply substitute, and e with ln cancels, so you just do 8 minus 4. 8 minus 4 is 4. 4 times 3, that's 12. That's it. So easy. Another easy one. These are fast ones. If you notice, the derivative of this is 5x to the power 4, which happens to cancel with this. So if you're that fast and you notice, you can just immediately go like, the integration of this is nothing but this, and then from 0 to 2, substitute, it's e to the 2 to the power 5, that's 32. E to the 0 is nothing but 1, minus 1. And this is a, this is b, so just add them up, you get 33, which is actually the answer. But if you don't see that, عادي, do ln, or let u, let u equals x to the power 5. So du, let's write it here, du over dx, because we're working with x, equals 4x to the power 5x, mixed up with the numbers, 5x to the power 4. So dx is du over 5x to the power 4, and this is why they cancel, because the integration from 0 to 2 of 5x to the power 4 times e to the x to the power 5 over 5x to the power 4 times du, these cancel, and this is why we got what we got last time, which is going to be integration of this, by the way, to this is going to give you, it's the same, oh sorry, I didn't replace, this is u, we said let u, so this is u. So this is why now it gives you the same integration, and then just substitute it back. You can use u, but get the limits. So put 2 into here, you get 32. Put u into here, put 0 into here, you get 0. Yeah, and just use the new limit. So you can say 0.32 of eu du. So you're gonna get e32 minus e to the power of 0, which is nothing but 1. So this is why. So you'll get the same thing here and there, 0 to 2. Yeah, you're gonna get the same thing. And then same thing here and there, this is e. And they just want these, so you add them up, you get 30. So for this one, 59, there's one rule that you need to know, which actually applies to the integration of e to the x, and a detail that we omitted. It's actually e to the x over ln e. Now ln e is nothing but 1, and this is why we have omitted it, because it's insignificant. So we did, it's not insignificant, but it's the same, it's going to give you this eventually. So the actual rule is, if you have an exponent other than e, a base, e is a base, here 3 is a base other than ln, let's put number a to the x, it's actually a to the x itself over ln a. And this is why in this case you will actually use this rule. Of course, when the exponent is x, when the exponent is something different, and different than this, you're gonna multiply, divide by the derivative. Yeah, I think I can double check anyways, but not now. Yeah, so it's integration of this 3x dx is gonna be 3x over ln 3 plus c. This is our function, and we want to put 3, so 3 to the power of 3 over ln 3. They said approximate ln 3 as 9 over 8. So 9 over 8 here. This is nothing but 27. Division by 9 over 8 is multiplication by 8 over 9. These cancel to give you 3. 3 times 8 is 24, which is actually the right answer.